welcome everyone from around the world to the third SWAN Digital Twin Workshop. First of all, great song by Queen, Don't Stop Us Now. Very appropriate for the digital twin community because as you can see, digital twin is definitely part of the conversation about holistic water utility management and is definitely here to stay. So there's no stopping this movement. My name is Gigi Edwards. I am the founder and the co-chair of the Digital Twin Working Group. Just to give you a brief history, this started about a year and a half ago when I collaborated with the SWAN organization to help create a working group that will really bring leaders together from around the globe to collectively focus on raising the awareness of digital twin technology for our water sector. And my goodness, has this idea grown and the collaboration has been monumental. As you will see today, we have leaders from around the world that share their knowledge and their experience for the greater good of the water sector. So now for a few key figures, this is really amazing. We have over 361 attendees from around the world. And when I say around the world, we're talking about over 28 countries are in this workshop together. This is really fantastic. And over 48 unique utilities that are participating. So I'd like to give a very special thanks to our co-sponsors, Edrica and Innovise. Thank you, both companies, for all that you do for Digital Twin. As you can see, they play a huge role in advancing digital twin technologies and other digital technologies in our water sector. So thank you again for your sponsorship. And now I want to share with you some of the members of SWAN that are actively participating in the Digital Twin Working Group. You can probably recognize many of these companies and utilities from around the world that are very active in digital twin concepts. I would like to invite everyone attending today to join us to help us create these better practices for digital twin technology. So we have a wonderful workshop planned with many opportunities to hear great speakers and participate in the roundtables. And now it is with great pleasure, I would like to introduce you to someone who will raise the energy level and help guide us through the entire workshop. Thank you again for our MC of the day, Travis Kennedy. All right, Travis, take it away. Thank you.
Oh, thank you, Gigi. Thank you, everyone, for joining us today. We have a lot of exciting things to go over for you in the next 4 hours. So I'm going to do my best to keep things moving and keep the energy flowing. I don't know if I can live up to the hype that Gigi just gave me, but I'm going to do my best. The first order of business is to go over the agenda. So what you should see on the screen now is what we're going to be covering over the next 4 hours. So after we get updates from the sub-working groups that Gigi will diligently review in a couple of minutes when I'm done talking, we will then move on to our very first panel of the day, which is Digital Twin Lessons Learned in the Way Forward. After that, we're going to get a 5-minute break. And then when we come back from that break, our panel number 2 is going to be Twinning in Wastewater from Concept to Reality. That will be headed up by Scott Branham. After that, we're going to have a 10-minute break. But this is where it gets a little funky because what we're going to be able to do is go from one meeting room to another. So we're going to actually be switching links from the webinar page to the interactive session link. And I'll give more instruction as we get there on the agenda. But after we switch links, we're going to be taking part in some interactive roundtable sessions. And then when we come back into the webinar link, we're going to have a 5-minute break to sort of catch our breath after what is bound to be some very exciting roundtable discussions and sessions, and then go right into panel number 3, which is Actualizing the Benefits of Digital Twins, headed up by Bob Taylor. And after that, we will supply some concluding thoughts, and we will also address any kind of salient points that were made and be able to review what we learned and what we went over for the day. So before we head over to hand it back over to Gigi, just a couple of housekeeping items for you to keep in mind as we go through the next few hours. First thing, check the chat box to download the attendee guide. There's going to be a lot of things that are going to be available for you in the chat box. And also use the Q&A box to ask a presenter a question. I'm sure there's going to be plenty of questions as the presenters give their information. So as they pop up, use the Q&A box that if you need to ask a question or would like to ask a question. Also, use that very handy chat box for any technical issues. You can send a private message to SWAN admin. So there may be some technical issues on your side. Please feel free to private message SWAN admin, and we will do our best to get it all worked out and get you up and running again. At 8 p.m., use the separate link and password for the interactive roundtable session. So all of that is outlined in your attendee guide. So if you remember, when we get to the roundtable sessions, we're going to leave this link and go to this separate link and utilize that password for the interactive roundtable. But again, I will bring all that back up once we get to that point in the agenda. And keep in mind too that all the presentations are going to be recorded and made available afterwards. So if you feel like you might have missed something, that's okay. All are going to be made available afterwards, and they're going to be recorded as they happen. So without further ado, I'm actually going to bring back the main eventer, our headliner, Gigi, who's going to go over updates from the sub-working groups. Gigi, the floor is yours.
Thank you, Travis. Thank you, everyone. So again, I'm just going to, along with my co-chairs, I'd like to just introduce some main ideas behind the Digital Twin Workshop, the Digital Twin Working Group. So if you can go to the next slide, Amir. So the Digital Twin Working Group, again, is a very collaborative effort. We're trying to bring people or leaders from global water utilities, from engineering firms, from solution providers, from government and academia together collectively to first identify some of the challenges moving towards digital twin and then come up with some best practices. So we had our very first workshop back in Miami, and that's the picture that you see here. And during that workshop, we decided that we're going to all try to really focus on a few key areas, solve those problems, and then move forward. So the next slide. So we decided to break up into sub-working groups or subgroups, and more on that later on from one of my co-chairs. But for right now, the idea behind this is that there are some objectives to these sub-working groups, and we're going to try to meet, twice a year with in-person meetings. That's what this is supposed to be, but because of COVID, we're doing it virtually, which seems to be working just fine. But if we ever go back, we would like to have 2 in-person meetings a year, and then in between those in-person meetings, we try to have conference calls to further, to advance the objectives of each of the sub-working groups. And then I'd also like to introduce a very special partnership that we have just had with SWAN and BIM for Water. BIM is starting to play a really big role in digital twin in the water sector. So this is a center of excellence from the UK that really focuses on BIM asset management. And this collaboration, I think, will further advance our objectives in the water sector. So now I'd like to introduce my co-chair, Colby Manwaring from Innovize, the CEO of Innovize, and he'll talk to you about some of the key concepts. Take it away, Colby.
Thanks, Gigi, and welcome everyone. So we thought we'd start here recapping the definition of digital twin. This is a statement that's on the SWAN website. You've probably seen it multiple times. I'm not going to read it. I'm going to call out a couple key items here. A digital twin contains the elements of a system. So what's out there? What have you got? What's in the physical world? You have to have some sort of representation of that. There are lots of ways to represent that. We talk about architecture and databases and so on, and we'll talk about that some more. But the second key part of digital twin, and the reason we have so many people collaborating here, is that it's not just the elements, but it's actually the dynamics or the behavior of those elements that really make a digital twin come to life and assist us as water experts, as planners, as engineers, as CEOs, as CIOs, etc., actually have informed insights about our water system or wastewater system, and we can make better informed decisions. When we can describe not only the physical elements of the system, but the behavior of those elements, then we have an opportunity to fine-tune in a digital world and then take that to the physical world, having tried a few scenarios and tried a few things out. So thanks to Colin Paris, who provided this statement. We borrowed it from him. a digital twin is not unique to the water sector. It's a thing that can be done in really any sector. And we in the water sector are just moving along and catching up in some ways. So that all sounds great. One of the questions that often comes out is, where do I get one of these? How do I get a digital twin? Can I buy one? Do I hire one? Well, a couple reasons we have this working group going. First off, one size does not fit all. The purpose of a digital twin may be different. The elements, of course, in systems are different. There are no two systems alike. So one size doesn't fit all. So that complicates our lives. Secondly, the reason we have this working group is, according to Orson Scott Card, one mind can rarely surprise itself. So bringing so many brilliant minds together is the reason that Innovise has been so involved in this working group and continues to support it. Is we think we're pretty smart, but there are many, many smart people, all of you that are attending here today, that can help us collaborate and really create a digital twin architecture methodology that allows, I guess, specific digital twins to solve specific problems for the life cycle of a water system. That's it for me. Thank you. I'm going to hand to Andrew to speak a little bit more about our work group objectives. Andrew.
Thank you, Colby. So from the beginning, we defined 4 main goals for our work group. It was to raise awareness, to identify the challenges, to develop best practices, and of course, increase adoption of digital twin in the water sector. To do so, we began with 2 subgroups. Today, we are presenting the 3rd subgroup, and as Gigi said, probably we will move to a 4th subgroup. But how do they interact between them to really get those goals that we want to reach? With the new subgroup, the life cycle subgroup, we will try to define the needs that a digital twin can solve for the different actors that are really in the water sector and all the phases, from design, construction, operation, or the final customer. To do so, we have the architecture group that's trying to find the building blocks and interfaces between these building blocks so that we can get a real high-performance digital twin, and soon the people from the subgroup will explain more clearly. And with these building blocks, we will be able to fulfill the needs and get outcomes. And these outcomes are the ones that in the outcomes and ROI subgroup, they are trying to clarify. And to do so, they are getting real examples so that we can show real application and show the real benefits that the digital twin can provide to the water industry. So I don't tell anymore. I give to Michael and Chenzi that will explain the next information.
Thank you, Andrew. This is Chengzi. Together with Michael, we are the co-chairs of the Digital Twin Technology Architecture Subgroup. Next slide, Gigi. Yeah, in this technology architecture subgroup, really our main objective is to define the core technology components of what is a digital twin, and also to identify the best practices in approaching this different technology. So it could range from data sets to different types of integration, different types of interfaces for integration, different types of software that you can connect with different technology, and obviously different models. What we plan to do is also to develop a high-level architecture diagram, which we have done, and we would like to collaborate and coordinate with the other digital twin subgroups. I'll just hand over to Michael, who would explain a little bit about the high-level architecture.
Thank you, Chenzi. Great pleasure that our subgroup is able to release this reference architecture for the entire industry. This was a lot of collaboration from a number of different individuals who helped us define those elements or building blocks as previously referenced, so that we not only talk about the technology, but the way this is going to change the industry through that new user experience, where we're able to provide those tools of answering major questions. And utilities will use this as they have been taking their digital journey, building different technology platforms to see how all the pieces fit together holistically. And I think that's really going to set the foundation for improved decisions and performance and create those actionable results. And to talk about that, the outcomes, I'll pass it back to Gigi and Colby.
Thanks, Michael. So the digital twin outcomes and applications subgroup. First off, if you are interested in joining this subgroup, you can sign up on the SWAN website, and please do so, or reach out to Gigi and myself. The objective of the subgroup here is to remind everyone that starting a digital twin without an end in mind can quickly become unmanageable. And so this subgroup was set up to help identify maybe some common outcomes people were looking for that we might share amongst ourselves here in this working group, and point to real world experiences. As I said, there's a lot of smart people here in this working group and in the SWAN workshop in general, and those smart people have done great things. So if we can point to specific examples, then perhaps if you or your organization is thinking of a similar application, of course, you've got a point of reference and a bit of collaboration. We've been working really to bring together some information on digital twins that have been implemented. Next slide, please. The next slide notes that we have now created a public survey link where if you have completed or you're in the process of building and using a digital twin, we would love to hear from you. It's a very short public survey link that is now live where you can put in some very brief details around outcomes, objectives, some technology, and perhaps some ROI statistics that this subgroup will collaborate, or excuse me, we will collate, put them in some common formats and share those with the overall group so that it becomes more and more of a reference list, a reference library, if you will, where we can learn about various applications. There are some good things going on. I got a couple that have already been submitted. There's the digital twin profile of Aegea in Brazil. Again, the idea behind our survey and sharing is identifying what are some of the problems that were solved, what are some of the benefits that were achieved, whether they're monetary benefits, operational benefits, or what might be referred to as soft benefits or social benefits. There's one example. A second example has been submitted already, Scottish Canals. So there's an organization where you wouldn't think, well, they're not exactly a utility, but you know what, they're heavily involved with utilities, and they have got problems to be solved: aging infrastructure, flood risk. You know, what were some of the key features of their digital twin, and what were the benefits achieved? This outcomes and application subgroup is all about, you know, real world practical application that we would like to gather and share so that, well, you know where to go look or who to go ask when you've got a similar problem or a similar outcome that you're trying to achieve. So again, join us in our subgroup. And with that, I'm going to now pass on to the next subgroup on the life cycle.
Hello, everyone. Good afternoon from Brazil. Yeah, first of all, I'd like to say that it's an honor to be part of this professional digital twin work group, particularly leading with Jim, the digital twin lifecycle subgroup. My name is Wagner Carvalho. Yeah, and today we are inviting everyone to get involved with us in this initiative, this new digital twin subgroup. Yeah, and I'd like to highlight our objectives to work together with everyone here. Yeah, first we aim to develop a education on concepts and examples of digital twins to bring the best operational practice experience to all asset phases, yeah? Since the design, through construction, till the operation, yeah? And we have an idea as well to create a diagram demonstrating the digital twin types and levels throughout a full asset life cycle, yeah? And yeah, Jim, can you explain the—
Sure. Sure, we'll also be gathering and sharing case studies within each area of the asset lifecycle. So some of the other groups have put out some requests and are looking at things like the value that can be gained with digital twins. The purpose of this objective is to identify what twins really look like across asset life cycles, right? If we're talking about planning or operations or design or construction. And also coordinate and collaborate with the other digital twin subgroups, both the two other groups that exist today, as well as the future groups that may be coming. Just to share what, and echo what Wagner had said, I'm looking forward to working with everyone that's interested in joining this subgroup and bringing together various examples through SWAN for this effort. Thank you. With that, I think I'll turn it back over to Travis now.
Sorry about that. I hit the wrong unmute button, but I'm back on video now. So thank you, everybody, for those updates. For the panels that are going to be coming up today, the moderators for each panel are very highly qualified people. So when I introduce them, I'm going to go over some of the highlights of their professional career, but that list and that description is quite long. So I don't have a teleprompter, so you're going to be seeing me read off of my paper here. I know that if Ryan Seacrest was hosting, he probably wouldn't need it, but he was unavailable for this and was, I think, SWAN's first choice. So whenever he's not available, it's Travis from Water Online that comes in and handles a lot of this. So the first panel that we're going to start right now is the digital twin lessons learned and the way forward, and that's moderated by Gigi, who everybody's familiar with. And a little bit of background on Gigi: she's an independent consultant of Carmus Edwards Consulting, and she consults on digital strategy and transformation, but now focuses on digital twin technology. She currently works with Global Smart Cities on integrating digital twin technology across sectors, applying her 25-plus year technical career in big data and Internet of Things analytics. Gigi recently founded and is co-chair of the SWAN Digital Twin H2O work group, which you were familiar with, to help accelerate the adoption of holistic water utility management using digital twins. She has a BS in chemical engineering and an MS in electrical engineering. And as I introduce each panel moderator, I'd like to interject some things on a personal note. And in Gigi's case, she considers herself to be an urban farmer that focuses on breeding microorganisms for the soil using Korean natural farming. This has worked well for her 25 fruit trees, herbs, and vegetable gardens. And then recently she spiced it up even further, and 2 years ago added a worm farm to the ecosystem to deliver even richer nutrients and microorganisms. So she is not only an innovator in the world of digital twin and the Internet of Things, but she is also quite the innovator when it comes to sustainability in her personal life. So without further ado, I introduce you again to our leader and moderator of panel one, Gigi. Gigi, take it away.
Thank you, Travis, and hello again, everyone. And thank you to all the co-chairs and co-leads for introducing the working group so properly, so thank you. Now I'd like to introduce the very first panel, and what a way to start: Digital Twin Lessons Learned and the Way Forward. We will start the panel with Pilar from Valencia, Spain. She's the head of water network control at Global Omnium. She's going to really talk to us a lot about their experience with digital twin. They're at the forefront of digital twin technology in Global Omnium, and what she sees moving forward with digital twin technologies. Then we're going to go all the way across to Singapore and hear from Arun, senior engineer at PUB. He's going to talk about their experience with digital twin and the impact that it's had on how they make decisions with their digital twin. Then we'll come back to Europe and hear from Jan in the Netherlands. He's a director of innovation at Beatons, and he'll kind of give a big holistic view of the role of digital twin across the water utility and how it fits into the holistic management of their water utility. And lastly, we will hear from Jason, advanced analytics leader from Suez. He's going to talk about a very critical aspect of digital twin, which is really about sensors and their reliability. As we all have heard, you know, bad data in equals bad insights out. So this is a very critical part of digital twin as well. So with no further ado, I'd like to introduce Pilar.
Thank you, Gigi. Hi, everyone. My name is Pilar Conejos. I'm the head of Water Network Control in Valencia, Global Omnium. I've been working for 20 years in the water management field, and since 2006, I've been working with real-time modeling and the digital twin project. I'm going to share my screen in order to start my presentation. I'll start my presentation speaking about the SWAN Digital Twin architecture. Then I'll speak about some lessons learned considering this architecture and our own experience operating WAIWA Digital Twin in Valencia. And finally, I'll speak about some next steps we are thinking about. Here we can see the main figures about our digital twin in Valencia. It's for the water distribution network. It contains 900 kilometers in length and the main regulating elements like pump, valves, and it's connected in real time with 600 sensors, so we can run live simulations. The platform that we are using is scalable, so we can implement this digital twin in other places. Here we have another example in Calpe. In this case, the digital twin contains 200 kilometers in length and is connected with 100 sensors in real time, so we can run live simulations in the same way than in Valencia. And in this slide, I show again the architecture agreed by the work group. And here we can see how for developing a digital twin, we need information from the physical system, and we need some components like data integration, analytics, and visualization. And now I'll speak about some lessons learned considering our own experience. First, it's very important to focus on objectives. We have to define beforehand the goals and the use cases for our digital twin. And we can ask questions like, which are the main challenges in our system, or what do we want to use the digital twin for? This is key because depending on the uses and the objectives, the development and the components of the digital twin are going to be different. We have also to analyze the system information, and we have to check if we already have enough information or not. And if not, we can plan additional installations. But not only that, we have to assess the data quality. This is very important because if we want to have good results, good insights with a digital twin, we have to feed it with right information. And we can do two things for that. We can improve our equipment maintenance, and we can develop data cleaning algorithms. They are going to be necessary because even with good maintenance, we are not going to avoid that sometimes we are going to have gaps in information or maybe wrong information because the sensors, the bases fail sometimes, and the communications also. Regarding the digital twin development, we have to implement a big data platform that concentrate, integrate, normalize all the information coming from the different sources, sensors or another business operational systems. This is very important and it's key also because with this platform, the digital twin is going to run efficiently and we are going to be able to maintain it over time. And this is important because as the real system, the virtual system, the digital twin is alive. We have also to develop or choose the simulations algorithms depending on the uses. And here we have a lot of options. We can choose deterministic algorithms like hydraulic models. They work very well for simulating the behavior of the water distribution network. We use it, for example, in our digital twin in Valencia. But we have other options like stochastic algorithms or AI that they can work very well for predictions or simulating complex systems. In the end, I think it's not, we don't have only to use one algorithms, we have to use all of them because every one has its own field of application. We have also to develop calibration algorithms. This is significant because the digital twin has to behave like the real system. So it has to be very well calibrated in order to have reliable results and we can trust them. And finally, we have to design a user interface according to the user. And a user interface, but an interactive user interface. Maybe the interface that an operator needs in a control room is different from the interface that a planning engineer needs. Regarding the user experience, we have to implement, develop as many capabilities as possible that allow us to improve the performance of the real system. Because in the end, the main goal of the digital twin is to improve the performance of the physical system, the real world. And finally, next steps we are thinking about. So far, we have a very well calibrated digital twin for the water distribution network. It has been very useful for us because we can test new ideas, new changes in the virtual system before making the decision in the real system. So we are minimizing a lot the risk. But really from here, the possibilities are enormous. We are thinking about adding more capabilities to the digital twin. For example, we would like the digital twin suggest us the best operation in any case. And as a consequence of the good results that we have obtained in the water distribution network, we are thinking about expanding this digital twin to other phases of the water cycle. Thank you very much. And now I'm going to hand it over to Arun.
Hello, everyone. This is Arun here. Let me first share my screen. So as I mentioned, I am Arun. I'm a senior engineer at the Public Utilities Board, the National Water Agency in Singapore. I've been working with PUB for the past 7 years, and I've been involved in reservoir water quality modeling specifically. And we've been working on developing systems for drainage operations and reservoir operations. So without further ado, let me jump into the presentation directly. So to give a bit of context on about Singapore. Singapore is one of the rainiest cities in the world, and it receives an yearly rainfall of about 2,200 millimeters on an average. The island nation also receives large amounts of convective rainfall, which have potential to create flooding situations in the city as such. Sometimes we also see precipitation that is about 40 millimeters within 30 minutes, and these are very common situations. And our flood operations team is always faced with problems on handling this and imparting the knowledge to the public in order to avoid flooding situations. As you know, Singapore is an extremely urbanized catchment. This particular digital twin that I'm going to be talking about is focused on the Marina catchment, which is about 10,000 hectares in size, and it's 1/6 of Singapore's total area. It has a very high, fast concentration time of 30 minutes, meaning to say from the top level of the catchment down to the reservoir, it takes only about 30 minutes for the water to flow down during a rain event. Marina Barrage is actually located bang in the middle of the central business district of Singapore, and it's a prime location, and hence there's a lot of pressure on the utilities to actually maintain the reservoir in a clean manner and ensure that there is no upstream flooding. So the reservoir is actually serving three different purposes. One is for water supply, for flood protection, and also for recreation. When we were developing the tool, the biggest problem statement that we had was that we had several different models that were being used in silos. We had operators actually operating the reservoir, conducting the reservoir operations according to their experience, and there was no integration between these two. So we came up with this decision to achieve an integrated water resource management system to provide situational and predictive information using data analytics and modeling tools. So we embarked on an R&D project with Suez, which began in July 2015 in order to develop such a user-friendly operations decision support tool. The outcome of the decision support tool was 4 main dashboards. The fourth one is not mentioned here, but it's a subset of the 3 dashboards that I'm mentioning: the Marina Barrage operations dashboard, the drainage operations dashboard, and the water quality management dashboard. So for this presentation, I'll be focusing only on the Marina Barrage operations dashboard, but I do have information on the DOPS and the water quality management dashboards if there are any questions after this presentation. So this is the actual dashboard that the operators see on the ground, and the key factor or the key takeaway from this dashboard is that it has integrated the actual workflow process of the operators on the ground operating the Marina reservoir. Meaning to say, this has information that the operators need to take critical decisions on the ground during storm events. For example, the first widget that you see on the top left is the radar widget, and you can clearly see the cloud movement and the rainfall intensities that are coming down at a particular region of the catchment. So this information is actually useful for the operators. Fine. Moving on to the next step, which is at the bottom left corner, which is the water balance widget. So here the operators actually need to know how much volume of water is coming into the reservoir and how much volume is going out. So the 5 different tributaries information is piped into the system, and the SCADA data is actually piped in to know how much discharge is taking place based on the number of gates open or whether the number of pumps are based on the pumps that are being run. The key part over here is also that the operators have an option to change into a trend view or a graphical format, which is explained in another video following this, where there is integration of a hydraulic model, which takes the data directly from the rain gauges and the radar information to actually have predictive flow of water that is coming inside the Marina reservoir. Following that, the most important part of this dashboard is this middle widget, which is the reservoir and sea level widget, which shows the comparison between reservoir level and the sea level. This is very important because the operators actually need to know when there is a crossover between high tide and low tide. For example, if there is a low tide and the reservoir level is higher than the sea level, you should operate gates. Otherwise, there is going to be seawater intrusion. If the seawater level is higher than the reservoir level, then we use pumps to actually pump out the water during storm events. The widget also gives information on the time to crossover between the different tide locations, and also the predicted water level that is going to come in during a certain storm event. And finally, after all this information is made available to the operators can look at an advisory module that is on the bottom right-hand corner of the screen, which is a strategy module. The strategy module essentially gives information on how many gates and pumps that are available to be run now and also 1 hour in the future. And it also provides advisories on the number of gates or pumps to be run in order to achieve your target water level. So meaning to say you can actually carry out energy efficiency calculations and save energy if you can actually recognize an incoming water flow into the reservoir. On the top right-hand corner, you can actually see there are blinking alerts for the operators to actually understand what kind of event is taking place on the ground. which is to define whether it's a big event that is coming in, or whether there's a chance of sea intrusion into the reservoir, or whether there's a chasing tide situation. So all these information is available for the operators to complement their operations currently at the reservoir. In the next slide, I will show you a video which replicates one of the storm events that took place in Singapore for your benefit. Yeah. So as you can see, the first widget is being focused upon here. The operators are able to zoom in, and you can see the rain gauges that are spread out, which are the sensors. You can click on any rain gauge and you get a time series graph of the precipitation. The bottom left widget is the tributaries flow or the water balance widget. This is the graphical representation. The dark green lines show the observed values, and the light green show the predicted simulated values. The middle widget is highlighted now, which shows the difference between the reservoir level and the sea level, and the predicted levels of the reservoir. Again, this also includes the hydraulic model behind the scenes to actually predict the seawater levels and the reservoir water levels based on the incoming rainfall. And finally, the strategy widget, which gives information on how many gates and pumps to run. Of course, there is also a SCADA tab. You can see the operators can actually see the status of the SCADA systems. And finally, the alerts widget, where they get information on any high tributary inflow or total inflow that is coming inside the reservoir. So moving forward, we are planning to expand and operationalize the catchment and waterways operation system, which is now it's known by, and we are planning to integrate several other models. We are planning to integrate 17 reservoir models, 17 operations dashboards for 17 reservoirs, and include 13 and 7 catchment models, including data analytics and optimization algorithms for complementing our operations. So finally, I would like to thank my project team within PUB as well as Suez, and thanks for your attention. Thanks. So I will hand over to the next person. Yeah.
Yes. My name is Jan Gooijer. I work as Innovation Manager at Vitens, and I'm responsible for the research and development agenda. We've divided our work in 8 different themes, and I'm going to present the one on hydroinformatics. Let's see if this works. Yes. Yes. So I'll just elaborate a little bit on the full-scale focus we have on the digital twin, and also show 2 cases that we are working on at the moment and have been working on for the last couple of years. Within Vitens, we have a research and development agenda consisting of 8 different themes, ranging from customer interaction to circular economy. And hydroinformatics is also one of the themes, with Hester van het Loo as the representative. She's also a member in one of the subgroups of this SWAN working group on the digital twin. Hydroinformatics for us is a topic where we want to have an overview on the entire scope of a digital twin. So it's both on data, but it's also on information technology. And our end goal is to find algorithms that help to automate solution providing for the different problems that we have, and to automate all the processes from source to tap within Vitens. So it's very easy to see it in one picture to get an insight in a digital twin, very close to the definition that we already discussed. But it has a huge implication, because it's well, it has to do with everything that is what makes a utility. And I've tried to quickly show it in this slide, where all the different aspects of a digital twin have an impact on the working and operations of a utility. On the top level, you see that we focus on process control, which is focusing on water quality and water quantity from source to tap. So it's about artificial intelligence, our production plans. It's about real-time insights in our distribution networks.
And it's also on smart meters at customers, at households, to get insights in individual water consumption, but also on water flow within a DMA. But for us, a digital twin is also a tool that can help us with asset management. So predictive maintenance, getting insights in the condition of our production plants, pipe inspection, robots that inspect our pipes, getting insights in leakages within households is also for us part of a digital twin, but not focusing on water quality or water quantity, but focusing on asset management and getting the condition of our assets in an optimal shape for the lowest cost. And finally, we also want to use a digital twin to optimize communication with our customer, whether a government or an individual customer. And so we want to be transparent about the water quality. We want to reveal the data concerning the groundwater levels. For example, in a period of drought, it's very important to show that we are not extracting too much water that is also important for other sources. It's also about automating communication to our engineers in the field so that they know what to work on. And finally, we also want to focus on customer interaction when they have complaints or questions, when they want to explain that they want to move, and we want to automate and optimize the process of the interaction of our customers with us. So you can see that it is a whole range where the digital twin is affecting our work. And it's all depending on good quality data. So data management and data quality is a key, and it's also very hard work to get it right. But it's not only data, it's also IT infrastructure. You need the IT infrastructure to optimize the working of a digital twin, and when you have programs, for example, that don't comply, then you have a big problem connecting all the different tools and all the different aspects of your digital twin. So for us, this innovation project, which is moving towards implementation at different levels, is in very close collaboration with our IT department, where you can see that IT management and asset management are woven into one company and need to work closely together to get the business perspective and the IT perspective to merge towards success. So this is the overall picture. This is our story when you want to have it on the highest abstract level. And we also have very practical examples where we are working on at this moment. One is a research project in the north of the Netherlands, in Wastewater, where we have equipped an entire DMA with smart meters and sensors also within the DMA that have the capability to get full insight in the water flow and water quality in all the different aspects and parts of the DMA. This Thursday, on the second day of the SWAN conference, we'll show a little bit more on this project in another session. So hang on there within SWAN to learn more about this project. Another example is focusing on our production plans. What we've done is install a lot of sensors, online sensors also within our production plans to optimize the functioning of the production plant. So like a very important step within our production plant is softening, water softening. And what we've done is optimize the sensor, optimize also the process of applying softeners so that we don't use too much chemicals, all the while making sure that the water quality remains constant. That's also hard work because you have different water sources, and from different water sources you get a different mixture of water that's coming into your production plant. So you need real-time automated response strategies to optimize the processes within your production plant. And right now we've implemented this as a monitoring system in all our production plants, and we are working towards a fully automated system that can help to optimize the water quality and the operations within all of our 98 production plants. And what you can immediately see is that these are very different topics. One is on a DMA, getting insight in a DMA on the water quality, getting insight in water consumption, and the other one is focusing on very chemical aspects within our production plants. And both are elements of what we consider a digital twin, even though they are very technical and very, on a technical level, far away from each other. And that brings us to the main challenge that we have at this moment. that we are making good start. We're getting results, and we are very happy with the results that we get because they bring in a lot of knowledge that is very valuable to us. But we also need to realize that a digital twin can have very different scopes and that it can be very difficult to integrate it into a fully operational digital twin. The more you integrate the different components of a digital twin, whether focusing on a production process or on asset management, the cost-benefit calculations become very difficult, but it's also very difficult to manage. So for us, it's a real challenge to see where you want to have a very dedicated digital twin focusing on one process only, and where you want to integrate it into a fully integrated system that grows in complexity with accompanying issues with maintenance and the costs. So that's where we are right now. We have the different components. We're very happy with the results that we've seen so far, but we are looking in a way to integrate it into a fully developed digital twin, all the while reducing complexity and reducing costs. Well, I realize it's a very short presentation, but I thank you for listening.
Hello, everyone. My name is Jason Nichols, and I'm going to talk a little bit today about some key elements within a digital twin model. So what I'd like to talk about today is sensors as that element. And you know, the SWAN diagram there shows that sensors are actually outside of the digital twin. And I'd like to suggest to the folks here that sensors should actually be inside of the digital twin boundary. And I'll show you a couple of reasons why I think that's true. So a little bit about me. I'm the Advanced Analytics Leader for Suez Water Technologies and Solutions. I've been about 10 years in research and development for water processes, and spent the 10 years prior to this at GE Global Research, working in water treatment and digital twin technologies, in fact. And that's a picture of me there, much younger, much trimmer and slimmer. Working in our water treatment facilities at GE. If you'd like to contact me, you can see the LinkedIn link here and my email address. Feel free to contact me after the talk here. So way back in 2015, I led a program that we called the Digital Wastewater Treatment Plant. And we teamed up with the folks at GE Digital, who were at the time creating the Predix the digital twin platform, and Simba, with In Control, to start to build the rudiments of a digital twin that did the entire wastewater treatment plant for a municipal system. And I'd like to share with you 3 things we learned from this program. The first is that data collection is expensive. I'm sure you all know that. And while you can get around this by having really large systems like a municipal drinking water system or a distribution system, you can kind of amortize the cost of sensors. As you get to smaller and smaller systems, like those of a wastewater treatment plant and even their assets, the cost of sensing becomes significant, and it costs money. And I teach courses about data science and machine learning, and I always tell my students, you know, data science doesn't beat science. So if you know that there's a model that actually models the behavior, use the physical model, because the data science model is trying to infer that which the physical model already knows. So here's a fun exercise is to take an Arrhenius model or any exponential model and see how many random points you could have to take from that data set in order to train any machine learning algorithm to accurately predict on the exponential, compared to the 3 points you need to know to do the same thing if you know that it's an exponential in the first place. And you'll see that it's hundreds, thousands, tens of thousands to get to high levels of accuracy. And so science always beats data science. Today I'm going to talk about the sensors themselves are elements in the twin, and we learned that during this program. The final thing I'd like to share is that we talk about outcomes in digital twins, and we had a lot of conversations with Colin and the team when he was coming up with that definition of a digital twin that was shared earlier, about outcomes and how you get to them. And the output from a digital twin is not the outcome that you really get. The output goes to a human, and the human has to do something in many cases in order to get to the outcome. So part of the digital twin overall design process has to include human behavior. It's the most complex part of the system that actually generates outcomes. And so here, design thinking, thinking about how you present information to a customer or an end user, thinking about that human-machine interface is often one of the critical but underappreciated components of the digital twin and how you actually achieve the outcomes. So today I'm going to talk about sensors, so let's dive in there. Here's a common problem that I've seen a lot, and that is you can create a really highly performant digital twin. You can create a very good model for lots of things, especially when you have good quality data. But when that model hits the field and it goes out into real life outside of your training environment, oftentimes you'll find either roadblocks to performance for a single asset. And if you are doing only one big system like a catch basin for a whole municipality, you don't really want to replicate that necessarily to the next catch basin anyway. So you usually only see the performance maybe not lining up. Or the scale. So in Suez and WTS and in my former life at GE, you would want to create a digital twin and then use it for the next version of that asset. You'd create one for an aircraft engine, and then you'd want to use it for all the aircraft engines that were of the same type. You do it for power turbine, you want to use it for all the power turbines of the same type. Well, getting to that scale would often break when you went to the field. And there was many reasons, but one of the common reasons was failure states of the sensor were not included in the twin. And the kinds of failures you would get were not that I didn't detect that a sensor absolutely failed, like it's just giving me stuck value, or it is giving me a physically unreliable value. It's that the sensor is giving you a value that's slightly off from what it should be giving you, either for simple reasons like it wasn't installed properly, calibration drift, bias drift, an event that causes the sensor to start reading differently. These things are not included in the state space of a typical digital twin. And if you're not careful when you're doing the continuous learning of a living digital twin, you'll learn the error right into the model, and it will start to drift further and further from reality. So how do you detect that, and what do you do about that? So what I'd like to say is sensors, they're not passive static observers that live outside of the twin. They are themselves components as much as a gear or a widget or a spinny worry thing inside of your plant. The sensors themselves are part of the twin. So here's a very simple idealized example. You're doing some R&D. You have a warning that a temperature for a particular asset, in this case my tea kettle, is greater than the specification for that tea kettle. If we had a digital twin for the tea kettle, there'd be multiple causal relationships that could cause that warning to happen. There is, of course, reality. Some part of the machine is working improperly. Someone turned the heat up too high. The metal on the bottom of the teapot is thinning and it has a higher heat transfer coefficient. Any number of things that we could model in the actual physical part of the tea kettle, or have gotten from data about tea kettles in general and created a model for. There's also another one that we're very cognizant of when we create digital twins, and that's the twin tuning itself, model tuning itself, getting it to reflect physical reality. And we're very good at finding model faults when models have themselves too much bias and are themselves either over predicting or overfit. Very, very simple and now almost in many cases automated to detect those types of model errors. But there are additional realities in the state space when you're actually in the real world that might not be considered when the twin was made. And these are things like sensitivity drift. Sensors fail and foul over time on slow degrade curves. So it's hard to detect them as they drift slowly away from their sensitivity that they got from at the manufacturer. In many cases, we expect the sensing ranges of a sensor to be linear over their range. Oh, Gigi's telling me I'm talking too much. Okay. We expect them to be linear over their range, and they're not. Any number of things. So to speed this up, there's a couple of things that I encourage people to include in their digital twins. Some sort of anomaly detection paradigm focused on the sensor distributions themselves, the aspect of sensor distributions that represent normal behavior for the system, and be able to detect when that distribution is moving away. Some good examples of using this that I like to use are Gaussian process models in a univariate sense. They can also be applied to multivariate sense, and this gives you much more accuracy in terms of detecting when a sensor is failing versus the actual system is moving into an undesired state. Quick example, simple tank level that we're doing today in Suez. Here's a trace of a tank level sensor in the upper left that was full, and each part of the sawtooth is the tank, being depleted and then refilled. And then at some point, something happened, and all of a sudden it was 3/4 full. And the question is that tank really only now being filled 3/4, or was there something that happened? Turns out that the field service agent on one of those refills bumped the laser depth sensor and caused it to be reading 3/4 full. That's an event detection problem that if you weren't including that in the twin, you might have never seen this problem. The second is, when you're looking at smoothing and high frequency data, sometimes sensor failure modes are happening at much higher frequency than the frequencies of your twin. So you have to look for those things as well. So model those sensor faults, include them in your state technicians for the twin. Use all of the digital data that comes off transmitters for sensors, include those in your twin. And where possible, have a physical model predicting what the sensor outputs should be in a multivariate way so that you can detect sensor faults as well. And with that, happy modeling.
Excellent. Thank you so much, Jason. Thank you to all the speakers. Those were wonderful presentations. I'm sure everyone enjoys those. And now we're going to go to some questions. I saw that there's a lot of questions. There's about 11 questions that were already answered. I hope everyone's looking at their Q&A here to the side of the panel. So let me ask one that's now, it's a general question. So when does a model become a digital twin? Maybe Pilar, you can take a stab at that one, and then we'll give it to.
When a model becomes a real digital twin is when the model can simulate the behavior of the network at any time, even in real time. So for having really a model that becomes a digital twin, you have to connect the Actualising model or the model with the real time. We have to be able to simulate the behavior under any condition and under any time. And obviously, it has to be very well calibrated.
Excellent. Thank you so much, Pilar. I think that kind of describes the answer pretty well. We have another question. This is for you, Jason. What are the oh, I think you answered that. Okay, well, let's do another one. What kind of technology do you use for data collection on the field in real time? And that's specifically for you, Jason, if we can quickly answer that. Good question.
Yeah, so we have a number of technologies that we use at Suez WTS for doing that. There are a number of cellular technologies that we connect to people's SCADAs and pull tags off their historians and transmit the historian data to our cloud systems for analysis. Those have latencies of between 1 and 60 minutes, depending upon when the cellular transmission occurs. We also have some OSI PI integrations that allow us to pull directly off of OSI PI systems and transfer them through either our cellular connections or direct network connections through what we call our edge box. The edge box is essentially a small computer, the standalone instance of our data collection system that then pushes through an API to our cloud-based data collection system through a variety of clients. And we typically have a number of clients that we custom make for folks as we bring them online. Is that what you mean in terms of collecting the data, or was it more the actual sensor sets and hardware that we're using for data?
So I think what we'll do for that is, I think that was a great answer, Jason. And if there's further questions from Dragon, if you want to go ahead and write that into the Q&A, and we can do a further subset of that question. Another one is, let's see, I think Pilar, you've already answered a few. So I was just wondering if there is a certain size of a system that you need for a digital twin to become economically viable. Are these likely to be viable for small rural supplies? And example, and I think this one, Jan, do you want to try to answer this one?
Well, it's hard to say if you need a certain size. I think to make it successful, you do have to start small. So we selected one production plant where we developed it from top to tail. As well as that we selected one DMA where we wanted to do the research on smart metering and getting insight in what happens within the DMA. And then based on that, we can strengthen the business case to really get insight in the benefits and to be able to assess them compared to the costs. You need to start very small where you are willing to spend a lot of money to test different sensors, different approaches. And then based on the results and the insight and the lessons learned, you can really develop the business case and then scale it up. And I think that's a very, very important approach. So I don't know what end scale you need to have. I think in the end, I think methods and models are applicable to any size. But the approach, start small, learn a lot, make a lot of mistakes, and then scale up is very key to success.
Excellent. Thank you so much, Jan. Here's another question for Jan, Arun, and Pilar about digital twins. So based on all of these conversations, it seems like the benefits appear to be mostly operational. Have capital expenditures been affected somehow in different systems as a result of having a digital twin? So who would like to take that first? And first of all, let me just say that, you know, as we talked about the sub-working groups, we do now have a sub-working group that's in the life cycle, and we'll talk quite a bit about digital twin in the design phase. But for right now, let's see, Arun, would you like to take this to start with this? About,
sure. Yeah. So typically, right, when you say digital twin benefits appear to be mostly operational, I think the digital twins can also be used for planning purpose, not necessarily completely for operations. So for example, in the Singapore context, we use digital twins or the models for assessing water transfer operations. So if I transfer a certain amount of water from one reservoir to the other, what's the impact going to be? And whether I can mitigate these impacts based on my model performance and model simulation results. Coming to the capital expenditures being affected in the Singapore context, actually, the capital expenditures do not really make much of a difference because it's all government capital infrastructure that the government has put in, and of course, outcome of your modeling simulations can impact in some way. So, for example, if my simulation result says that I need to do something at this location, then I might be able to propose to my guys to say that, okay, this needs to be installed here, and that might affect capital expenditure in that sense. Yes.
Thank you, Arun. I think that was a very good answer. And more to come on that subject, by the way. Here's a question from our friend Lori Reynolds. I was pleased to hear Jan talk about the integration. What have been the approaches to have been most helpful managing this challenge? So Jan, do you want to take this one?
Yes, and I'm very pleased with this question because I think this question really is the key for this digital twin work group. Yeah. I'm very pleased also with the different subgroups and the overall picture that was shown at the beginning of this session. I think just this picture where you see that models are just part of the entire ecosystem of a digital twin really shows that integration is a topic that needs a lot of work, a lot of collaboration to really explore the value, but also the challenges. And the reason why we're together and sharing the knowledge, but also working together in working groups to develop the more philosophical side of developing this is part of this integration process. So this is one of the things that we have to do in collaboration and learn from each other, see the best practices, and see how we can optimize this, because this is a question that is still unanswered, where we can work on together in the coming years.
Perfect. Absolutely agree. 100%, Jan. Thank you so much. Thank you to all of our speakers. This was a fantastic panel, a good way to start the workshop. Really appreciate all your time and all the great questions. And so now I give it back to Travis. Thank you, Travis.
Thank you, Gigi, and thanks everybody. That was a lot of good information there. So I think what we're going to do now is just give everybody some time to digest some of that information and take a 5-minute break. But before you take that break, you might want to stick around for a short sponsor video from Drika.
Travis, you're on mute, but you can go for it when you're ready.
Hi, everybody. Welcome back. I hope you had some time to digest all of that wonderful information that was given to us in the first panel, and we have an exciting one waiting for us right now as well. So panel number 2, which we will begin momentarily, is Twinning in Wastewater, From Concept to Reality, and that's moderated by Scott Branham. Now, I always like to, again, give a little bit of a personal note about our moderators, and then get into some of their background as I introduce them. For Scott, some of you may be aware of the Matthew McConaughey movie called The Free State of Jones. Well, believe it or not, that was actually about Scott's direct relatives. So if you ever run into them out on the road or at some conferences or are talking with them, that is certainly an interesting fact that could create some pretty good banter back and forth. If on a professional level, Scott has 26 years in the water treatment industry with broad-based experience in sales, marketing, operations, quality, business excellence, and in digital. He's credited with developing Evoqua's first IoT solution, digitally transforming its largest product by revenue, which is saying something. Scott continues to drive Evoqua's journey into the digital age, currently managing 12 active transformation projects that range from sensor development to complete inline business transformations. He graduated from Auburn University, War Eagle, with a BS in biochemistry, and he is a certified Six Sigma black belt, so nobody mess with him, and holds a number of patents in the IoT and chemical manufacturing space. So without further ado, Scott, take us away.
Outstanding. I'd like to welcome everybody to the SWAN 2020 panel, Twinning in Wastewater, From Concept to Reality. And I am going to share my screen here. Excellent. Sorry, there we go. Excellent. Yes, and before we begin, I'd like to introduce our distinguished group of panelists. We have Steve Riches, Head of Bioresources for Anglian Water, Mark Penny, Chief Operating Officer for Business Modeling Associates, Amanda Hahn, Senior Hydraulic Modeler, and Peter Vale, Engineering Information Manager for Tideway, Matt Davenport, Solutions and Technology Regional Director for Jacobs, and Jan Krychak, Director, Market Development for Urban Water, DHI. So our agenda today will consist of 4 brief presentations that build on one another as we explore digital twin journey from concept to reality to business value. Those presentations are how to begin to think about implementing a digital twin, practical development methodologies, journey from implementation to business decisions and value, and we're going to wrap up with real-world application and a discussion on how one company actually created value using digital twin technology. After the presentation, the forum will be open to the audience for questions, and the panelists will also be discussing a few of the presented concepts in a little bit more detail. And we'll close with final thoughts if we have time from each of our panelists. Very excited about this, but a few housekeeping notes before we begin. Please remain on mute. If you have the ability to come off mute, just please remain on mute during the presentations. Our goal is to move beyond the theoretical. It was interesting with a lot of the questions that were asked. A lot of the questions were asking about just how to even begin. And as I've attended many of these type of presentations in the past, they're often very much in the theoretical level. And we're trying to bring this down to something that's much more concrete. The desire is that everybody on this who's listening and participating to have something actionable that they could take with them and to move their digital journey further down the road. But most important, this panel is for the audience. It's meant to be engaging, it's meant to be interactive, and we have as much to learn from you as you do from us. So with that, I'd like to introduce our first presenter, Matt Davenport, as he presents how to begin to think about implementing a digital twin.
Thank you, Scott. Yeah, I'm happy to be here. So first, just a quick introduction of myself a little bit more. I've really, my whole career has been around the utilization of digital twins and modeling of not only hydraulics process, but also your operations and controls and utilizing historical data and coordinating with SCADA. So been doing it for a decade, and so in the water industry is my passion. So I'm sure many of you have seen this slide, or has at least seen this diagram that's wonderfully made, that really does a good job of describing a digital twin, right? And where it ties in with the physical system. So as many of the presenters before us have discussed, you know, there's the analytics, the data-driven models, the physical-based models, various types of models software is used to analyze the system, which incorporates data, right? So you need an aspect of data integration that really links to your sensing, your controls, to your assets. It could be your operational strategies. It could be detailed controls, PLC controls, and the attributes, maybe geospatial, of your physical system. So really you're trying to incorporate this data and digest this data and analyze this data in a very detailed and complex manner. And really taking those analytics and being able to visualize it. So we've gone from writing with equations to spreadsheets to models to integration with sensing controls and data, to the point where we are now, where we're getting 3D visualizations with applied applications of operations and such with it. So I really bring that into the table here because we really, moving forward, are going to discuss that. So there's the various project phases that we do this digital twin on, right? It's the design, then it could be used for construction, facility startup, and operations. And depending on where you start, really has an impact on where your journey begins and where your journey will go forward. And can you go forward, actually? 2 slides. I won't have control that I know of. Scott? There we go. Go one more. There we go. Maybe I have it. Yeah. So then why do we do a digital twin, and what do we build a digital twin of, right? So it all comes down to 2. There's the most important aspect is the business case. So what is your long-term value that you're trying to get from your digital twin? And we've heard this before, and people have hinted at it. While really understanding what our long-term business case is, there's really the ability to be able to identify those quick victories and have an agile development mentality when developing your digital twin will really help add value along the way and help you develop a digital twin that has a long-lasting impact on optimizing the system and better understanding of the system. So this graph on the right really shows how a digital twin comes into play in every aspect of a physical asset's life cycle. So, you know, you develop this twin to really represent the system so you have better assurance of the decisions that you make and the interventions that you've developed are going to be resilient and be feasible. You know, for the digital twins life cycle, it really is an iterative process, and you're continuously updating it and enhancing it along the way. So things to look and to consider are your structure, like what is our missions for this digital twin? What are we trying to achieve? You really need to look into your people, right? What people who are going to use this, and what does it mean to them? What process are you trying to develop? And really this is, what are we looking at, a whole distribution network, wastewater system, a specific pump station, et cetera. And then really who are your long-term owners? Who are your advocates? Who is going to hold the flagship of this digital twin long-term? Because without that, the digital twin will do like models have done in the past and essentially die on the shelf. So, you know, when you're developing your digital twin, those are the things you really want to consider. Next slide, please. So when taking that all into consideration and we're wanting to bring a digital twin to reality, you got to start somewhere. And the graph on the left really brings us to the point that some people ask, well, when does a model become a digital twin? How expensive is it to develop a digital twin? Well, it depends on where you start digitally and how mature your client or your assets are, you know, how digitally connected you are. And then really along the way, every path of a digital twin varies, right? And some of them may stop during that transition to a truly connected digital twin. And what we like to call in Jacobs a digital replica is that aspect where you're getting almost there, but maybe you don't have some of that IoT or some of that interconnectivity that people will expect, or maybe it's associated with your assets that people will expect to be considered a true digital twin. In our case, we really do think that a digital twin is everything from the smallest to the biggest, and you're just looking for that scalability that's really bringing added value throughout the life cycle of the asset as well as your digital twin. So the takeaways are really, a digital twin is not just one software. Someone asked this as well. It's not just one model. It's an ecosystem of softwares and tools that are utilized to represent your system and to give you answers of your system and to help visualize and solve problems, right? Developing it it's got to be strategic, really. I said this before, but you really want to make sure you get those quick victories to get buy-in from all your stakeholders involved, and really to gain momentum and better understand where this digital twin is adding value. And lastly, I like to say this is that the maturity of a digital twin varies, and the mileage will vary depending upon what we're trying to solve and what the maturity is of the digital transformation of an asset, of a system of utility may be. So I really wanted to bring that up and then hand it over for our next people to discuss from there. Thank you, Scott.
Thank you, Matt, for that insightful presentation. The SWAN Digital Twin concept provides a nice framework to begin thinking about the journey. It includes, it also includes the digital maturity needed for it to be successful. I thought those are very key points. But now we're going to move to Amanda Hahn and Peter Vail from Tideway as they take us deeper into the journey by exploring practical development methodologies. Amanda, are you ready? There we go.
Make sure you're not on mute.
Yep. Okay, Amanda, we can see your screen, but
sorry, I was on mute. Okay, let's start again. Right, okay, hi, I'm Amanda, and I look after the digital twin of the existing London sewer network and the proposed London Tideway tunnels, which I'm going to talk about. I've been working on this project since 2008, and I'll be joined by my colleague Peter Vail, who manages the Tideway digital strategy and the delivery of all the engineering informations from our main work contractors who are building this tunnel. Right, so just to start off, a quick overview of the project. The London sewer system was built sort of in the late 1800s after the Great Stink of 1858, and it's still used today despite population growing from 2 to more than 8 million, and the expanding urban landscape as shown in the two contrasting maps at the top. As a result, 40 million tons of combined sewer overflow is discharged into the River Thames more than 50 times in the typical year, sort of due to the overloaded treatment works and sewer system. So the solution is the London Tideway Improvement Project, which includes this project and the Thames Tideway Tunnel. Completion of this tunnel will control the remaining most polluting CSO along the tidal Thames. On the bottom are some of the key information on the project, but the key point here is really the 1.6 million cubic meters of additional storage that we'll be adding to the existing network, and the challenge we have to manage its use effectively and safely once it's operational. Our digital journey for operational use began in 2019, where the completed system will be a key component for successful system commissioning that is due to start in October 2022. So why the need for the digital twin? They're really summarized in 3 broad categories, starting with this. The first is a knowledge tool for optimizing and decision making. It is mainly used to support go, no-go decisions during commissioning activities, but long-term, as highlighted in blue, during operation, it becomes an essential tool for analysis and continuous learning. First, in optimizing the operational protocol, which is weather dependent, and second, really to ensure seamless integration with the existing treatment works, the sewer network for effective tunnel operation for CSO control. Second, as a training tool for upskilling the end users. These are the Thames water operators or the decision makers and management. The digital twin provides us a place to learn and test the tunnel system without really worrying about breaking it. And finally, it's a management tool for demonstrating regulatory compliance and overall fit for purpose of the physical asset. This includes ensuring compliance with the agreed London Tideway Tunnel operating techniques with the Environment Agency here in the UK. And ultimately, it is to show that the annual CSO discharges now complies with the Urban Wastewater Treatment Directive. Essentially, we are striving for better information and analysis, which leads to better decision making, which will improve operational efficiency and save money. And how do we create this digital twin? Really through a step process using existing digital twins and then with incremental improvement, which I'll talk about. First, you here on this slide, you see the existing ICM strategic model of the current physical assets that has been used for over 10 years with other data sets, including the ANSYS CFD models and the physical models to develop the reference design and the operational control of the London Tideway tunnels. These models are used in a connected way and maintaining a feedback loop to help improve each respective model. Now, working with Thames Water, we also recently upgraded the strategic model into a more detailed model to ensure that we align with what Thames Water is currently using. And on the incremental steps, the next step we did was to develop the ICM Live version of the twin to transition it into a more dynamic digital twin. Forecast rainfall and tide levels are used to simulate the digital twin near real time, and really it is to create an alert and alarm system for operation and decision making. Here's an example of an alert of rainfall, but this alert could be for any component within the digital twin. Key data sets such as these graphical or CSV format can be produced as well. So this tool for us is critical for giving near real-time decision making during commissioning. So therefore, early stakeholder engagement is essential to sort of define the alerts and data needed to make sure we generate purposeful data. And finally, the next piece of the digital twin is really to bring this dynamic modeling platform to an accessible, user-friendly environment for the users. To do this, we are using Replica to build a flight simulator version of the London Tideway tunnels. It uses source information from ICM, and it creates that critical interface similar to SCADA where operators can feel more comfortable with, and it allows them to safely test drive and practice tunnel operation and decision making during storms, including the important infrequent failure mode and contingency operation testing. By connecting these data environment and to work together, we've created what we like to call the virtual operating system. And just finally, the last slide sort of brings together some of the key points for creating the virtual operating system highlighted in the text below. By combining really existing digital twin and creating an end product that is user-friendly system to simulate, test, and operate the physical assets, we can demonstrate the successful integration of the Thames Tideway Tunnel with the Lee Tunnel treatment works, the wider sewer networks, that they work together as one integrated system. And this picture just sort of concludes by showing two worldviews. You've got the modeling and you have the operational worldview. We can keep to the modeling worldview or we can expand it. And the virtual operating system tries to do this by creating that accessible and familiar operational platform, which is key to ensuring that the digital twin has a lasting impact on the main users of the system. And more importantly, that we do not retire yet another model into that digital library when the project is completed. So essentially, I think the theme is let's try and create an end system that everybody wants to use. And just to finish, I'd like to acknowledge that the creation of this London Tideway Tunnels digital twin was only possible with close collaboration effort between Jacobs, the consultant, Tideway, our client, and Thames Water, the end users of the system. Thank you.
Hey, thank you, Amanda. You know, most often we think of a digital twin effort as a greenfield type of project. It was very interesting to see how existing programs were incorporated into the digital twin ecosystem, maturing them and allowing them to be both scalable and sustainable. It's always encouraging to hear a focus on the platform being user-friendly and becoming a real-world tool that gets used every day and by the stakeholders. So that was very exciting to hear about everything that you've been doing. So now building a digital twin is a journey. We've been talking about that. Jan Krajcek from DHI, he's going to be taking us further down the road as we move from implementation to business decision making and how that journey continues. So Jan, I turn that over to you.
Thank you, Scott, for handing it over to me. I would like actually to move a bit forward around, as you said, with the example of how this digital twin can be applied for the wastewater treatment plants. You know, I picked this kind of example because the wastewater treatment plant is kind of infrastructure that actually is well defined in a way of how it works and what is the purpose of it. And one of my predecessor in speaking was talking about, let's say, what is the, and there were questions about what is the size of the infrastructure, or what is the size of a problem, or the system where the digital twin should be applied for. And I would, in this kind of example, I would like to demonstrate it probably whatever kind of. You know, there are only United States and European Union more than 50,000 treatment plants in operation today. And of course, let's say we were talking very many times about the larger ones, but you know, there is hundreds of thousands of the smaller ones which are having the same impact on the environment, and any kind of technology who is going to help, let's say, with operational status and operational achievements of that kind of facilities is a benefit of it. I'm Jan Krajcek, Market Development Director for Urban Water in DHI, and being a DHIer, we were actually talking about digitalizing the world of water, let's say, for many years. And this picture here was drawn by my colleague Cheng Zi, who is actually part of the SWAN group here. And I like it because it shows, let's say, that there's a different maturity of digital twins, from descriptive kind of systems using the data and machine learning for that, up to the very upper corner to full digital twin using the model online, real time for decision making, and even automation and control of the facilities. And I'm not showing this because there is some sort of very, let's say, deep scientific message in it. What I would like to demonstrate here is that within the process of creation, and several speakers were talking about it, it's quite important not only to think about the processes and the facilities that you would like to digitize, but also for those who are going to use it, you know, because let's say the people who are going to use that kind of digital twins are those who are making the decisions at the very end, whether the digital twin is going to be used or forgotten. And for the wastewater treatment plant, well, we were talking, all of us, about the integrated data and models and decision-making tools. But I would like to highlight that, let's say, the stakeholder engagement and value creation through the entire process of creating the digital twins probably is the most decisive, let's say, component, whether the final work is going to be used for good or whether it's going to be actually somewhere on the shelf of another visual model of that. And not only because stakeholders are engaged at the beginning and through the process, but also the stakeholders are taking, let's say, the training, or they can be actually trained by the knowledge transfer, co-creating the digital twin. And for the treatment plants, there could be a different level of people. It could be, let's say, the guy who is operating in the field, but it could be also, let's say, the CEO of the water utility, getting, let's say, the different information about how these plants are operating, and whether there is something, let's say, to learn from it, and so forth. So the knowledge transfer by training is another component of creating the digital twin into the reality. And demonstrating a couple of examples, whether we talk about integrated with this existing SCADA system, where the people at the control room can use it, let's say, in the environment that they are used to work with, as the example on the upper part of my screen for one of our treatment plants in Germany, let's say, using the model of DHI within the Siemens PCS7, let's say, user control, or whether this is model-based control strategies. Well, this is, let's say, using some dashboards about where the treatment plant is now and what is going to be taken next steps, or whether there is a true fully customized decision support system when you take the decisions on your treatment plant, like the upper bottom example from China that we have developed for one of the customers. It doesn't matter too much, right? what matters is what the final user is going to use the system for, and how the value is creating for business. So there might be several or many KPIs that the operator of that digital twin, and in this case in wastewater treatment plant, can be actually focusing on. And whether this is reducing operational cost or increasing capacity or reach a stable plant or whatever it is, through the real-time data-driven application, it's something that they have to be involved in the process. So bringing the concept of digital twin into reality on that kind of examples, it's not only to bring together the processes and facilities to digitize, let's say to use the nice models, but also to involve the people in. And this is what we do in the HR. Thank you very much for your attention.
Hey, Jan, thank you so much. That was great. You know, one of the key things you talk. What, are you done?
Yeah, sure.
Yeah, okay, so make sure. All right. You know, you talked a lot about transfer of knowledge and to enable a resilient digital twin program. You know, and also within a COVID-19 world, being able to solve problems or optimize systems remotely, it's absolutely critical. And most importantly, your point on the enablement of users, right? Thinking about that end user to make real-time business decisions is absolutely spot on. That's what this is all about. So very well done. Which brings us to our final presentation by Steve Riches of England Water and Mark Penny at Business Modeling Associates. And they're going to be quantifying the actual business value of a digital twin used for processing waste treatment sludge, not the water, but the actual sludge itself. Go ahead, Steve.
Okay, well, thank you. Hopefully you can see my screen and the slides. Right, I'm Steve Riches. I'm Asset Delivery Portfolio Lead for the Bioresources part of our business. I've been Angling Water 24 years, and for the majority of that time I've been working in the bioresources side of the things, and spent a lot of my time looking at strategy, capital delivery and into operations. And the past 3 years I've been working very closely with Mark and his team in developing our digital solutions to support our bioresources business stream. So I'll hand over to Mark to introduce himself.
Thanks, Steve. And I'm Mark Penny. I'm the Chief Operating Officer of Business Modeling Associates. I was just reflecting, actually last week I celebrated my 39th year in the water industry. 30 of those were with Yorkshire Water, but for the last 9 predominantly working with Business Modeling Associates. And what we're going to talk about today is the reality, and it's about moving beyond data to creating value. And we're going to talk about the implementation of an advanced digital business twin to optimize the end-to-end of a bioresource value chain. We're going to talk about 3 things really. We're going to talk about what's the business problem we're trying to solve, how did we solve it, and then it's all about show me the money. What benefits were realized and what other tangible benefits did the organization see as a consequence. So Steve, over to you.
Right. Okay, so as Mark said, what was the problem we're solving? Well, within Angling Water, our bioresources operations are very complex, right from the collection of the sludge, the transporting it to our centralised sludge treatment centres, then the recycling of our treated product to our farmer customers, and the generation of renewable power. As you can see on the map, we are the largest geographic water company serving England and Wales, and we have a very dispersed network. So we have over 1,100 water recycling centres all producing sludge, and that's brought down into 10 sludge treatment centres which operate advanced anaerobic digestion with power generation from CHP, producing fertiliser products that we sell to our farmer customers. Traditionally, these activities have been undertaken across multiple teams and multiple stakeholders, and they've traditionally worked in quite a silo mentality in a way, so they'd each have their own operations budgets they'd work within, and there was not a clear end-to-end view of the value chain. Just to put things into context, in principle, any sludge that we produce can go to any one of our 10 sludge treatment centres. And that would mean up to 93,000 different permutations on a daily basis that we could run. So you could see that was giving us a clear need for what we wanted with regards to producing a digital representation of our network and how we could use that to give us better decision-making capability. So the two objectives we had initially was to help us inform and build our future price review business plans. So looking at a 25-year investment strategy in terms of where to invest to build additional capacity to meet our needs and at what time we should do that. And the second point is around operational planning. So what are we doing in the here and now to optimize our network to drive value out of that end-to-end chain? So I'm now going to cover a little bit, just to give you a flavour of some of the inputs and outputs for the model and how that supports our decision making and balancing risk across the network. This first graph is an output of the 25-year model. So it's running, looking from 2020 right through to 2045 in annual investment chunks and looks at impacts on the network as a result of growth. So again, Angling Water, we're one of the highest population growing areas in England. And also the impact of water quality improvements within the wastewater network in terms of how that means we have additional sludge to treat year on year as we go through the period. So the model helps us make investment decisions in terms of when and where to build that additional capacity. This is just an illustration of some of the options that came out. The second part is then how do we use these tools in order to help us in the here and now in the day-to-day operations. So the second model is a 12-week look-ahead model that we run on a weekly basis through a production manager. He then liaises directly with the operational teams and our department that do the logistics and final product recycling to plan in weekly look-aheads. The graph on the screen is just sort of showing and putting into context the challenge of some of the things we're trying to address with the model. So the blue curve on the graph represents the weekly sludge production that we have in Angling Water based on historic data. And as you can see, at times we have more sludge than we have treatment capacity if we accept we're looking to run our network at a 90% availability when you allow for downtime and maintenance. So what the model allows us to do is on a weekly basis input data in terms of process performance and availability of the individual assets. We can also forward plan for maintenance intervention and the timing of those interventions. And equally, we can also decide and make decisions around how and when we balance our stock levels across our inventory and also where we can flex the network capacity for sludge treatment centres beyond their design average to cope when we have high sludge stocks. Equally, it allows us to provide a clear view on when we should be balancing and using storage available to us, or whether we should bring in temporary plant to peak lot production capacity, or we should be utilising new markets and trading with our neighbouring water companies or third parties. Okay, Mark's now going to talk a little bit about the modelling software itself. Over to you, Mark. Oh, you're on mute, Mark.
Apologies, I got a bit of a cough, so I went on mute. So the first, I'm going to talk about what we implemented. So the first thing we did was we implemented the Decisio, which is BMA's unique digital business twin platform, and to that we configured the Anglian Water bioresource asset base, all its detailed financials, and created a baseline of the solution. That could have been a water network, it could have been an energy network, it could be anything. Basically, we've got a platform that allows us to configure a asset base and a business process. From that, Steve, we then did effectively, we set about analysing. So if you click on the next one, so we set about through the use of a detailed user interface, an intuitive user interface, we started to analyse the problem from the point of view of the production planners. So the production planners interact with the system on a weekly basis, and they're doing things like changing asset availability, capacities, they're updating constraints within the network, they're looking at scheduling planned outages, and they're looking to how to deal with response to asset failure. All of that then goes into create a new plan, which goes across to the optimization model on the left-hand side. So the optimization is run by the production planners. They do a solve. The solve then returns effectively an optimized plan. So that goes across the right-hand side. The optimizer produces effectively a kind of series of visualizations in an integrated Power BI dashboard. That is the new plan, which is then shared across the bioresource business area. And the plan is then executed to deliver the optimal plan for operation for the entire bioresource business for that particular week. So that's how we kind of implemented and solved the problem. Back to you, Steve.
Okay, so we've been running the production plan for just over 12 months now, and we've really seen some great benefits that have come from that. I think what it has enabled us to do is have that clear view end to end from the collection of sludge all the way through to the end product recycling. It's enabled us to put more of a sort of factory mentality approach around our sludge treatment centres. The result of that is that we've treated more sludge through our 10 sludge treatment centres than we ever have before, and we've managed to both increase the average performance of the asset base and also the availability, and we've managed to achieve our target of 90% asset availability across the network, which we hadn't previously done. We also then generated the most power that we ever have done from our biogas at 114 gigawatts last year, and we're on target to increase that further to 120 gigawatts this year. All of that has resulted in a reduction in the cost of the end-to-end cost of treatment, including the logistics of treatment and the recycling part. It's fair to say that whilst the treatment and recycling part of the unit cost has decreased, we did see an increase in our transport logistics, and in many ways that was to be expected, because we wanted to make sure we were focusing sludge in on the most efficient and lowest cost treatment centre, so again to drive that end-to-end behaviour. It's also enabled us to make better in-year investment planning decisions as well. So when we're balancing risk across our businesses in terms of water recycling and bioresources, and making those in-year investment decisions, we've been able to use the model to determine how this particular risk would sit against other risks in the network, and then promote investments on that basis. If we look back at our cost base for bioresources prior to the implementation of the models and moving to this production-based approach, system-based approach, we've unlocked around £2 million of operational cost saving per year. So that's giving us a rate of return on investment of around 6 months for the project. And with that, I'd like to say thank you for your time, and I think that's us finished. Thank you.
That's outstanding, Steve, Mark, appreciate it. You know, digital twins are typically thought of in the fluid part of the waste treatment plant, at least everything that I've ever seen as far as examples and things like that. So it's been absolutely fascinating to see how that the concept was used to optimize sludge management. And not only that, but you had over 2 million British pounds in return on that investment is not insignificant. So it's one thing to have a digital twin, it's another to to actually create an ROI. But those were 4 outstanding presentations. They provided a very high-level overview of the thoughts and steps needed to develop a digital twin. We'd like to open up to questions, and I think there's no open questions here. I guess maybe Amanda responded, but I do have some follow-up questions. And so I'm going to open up this one to Jacobs and Matt over there. Digital maturity is always something that keeps being talked about. It's a key parameter. It needs to be evaluated. It needs to be understood before starting the digital twin journey. I heard people mention that a couple times. Is there a minimum maturity level threshold required before beginning that implementation? And how would somebody go about assessing that?
Yeah, that's a very valuable question. I think it needs to be discussed more. When we talk about these projects, and a lot of these are fantastic projects, and hopefully we had a scalable shift there that we discussed from what Amanda and then we're doing at Tideway versus what Mark and we're doing. But to answer your question, I think it really depends on what the ultimate goal is, right? So you got to have a starting point, and then you have an end point of where you want to be, and that digital twin endpoint can fluctuate, right? So I don't see it as a to start your digital twin journey. I don't think there's a minimum. I think what you can do is utilize that as an opportunity to become more digitally transformed, right? More digitally connected to upgrade things. I think you can look at it in a lot of ways to just make progress. So my short answer is no, I don't think there is a minimum. Others may have a different opinion on that, but I think if you strategically work to strive for that digital twin and find those quick victories, as I call them, along the way, yeah, there's no minimum from a digital connectivity in my mind to get the journey started.
That's excellent. Does anybody else on the panel have any thoughts on that?
Yeah, can I add? So in the UK, we're quite lucky that the UK government are actually sponsoring the National Digital Twin Programme. And part of that is linking up with the Infrastructure Client Group. So both Anglia Water and Tideway are both members of that. And there's something called the Smart Infrastructure Index, which came out of the Institute of Civil Engineers Project 13. What that does is it basically tries to, through a questionnaire, give a gauge of what is your sort of maturity, and it covers a number of areas around delivery, around digital twins, customers, etc. But what it does do is it at least gives you a starting point to get an understanding of where you as an organization are, where the industry is, and based on that, it's not to define whether it's right or wrong, but it's really to give an idea of where you are and then plan a strategic way forward to realize those benefits. So unless you know where you are on that journey, it's quite hard to start. So, and what that does is that shows you where you may have some weakness in your organization, where you can focus on those quick wins.
Thank you, Peter. I appreciate that. Another question. Yeah, on this one, I'm going to direct towards you. What are some of the barriers and what are some of the enablers to deliver a connected ecosystem of digital twins? What are some of the things that you've seen out there in your experience?
Well, thanks, Scott. I mean, it very much depends on, let's say, what is and Metal Reacts, let's say, address that. What is the final goal of that? But the enablers are usually, let's say, not only the maturity of the physical systems, but also preparedness of the stakeholders, and then finally the end users to involve themselves into the process of building. We usually speak about when we say what is the right maturity and what might be the right data for implementation. We understand it as a kind of data coming from sensors, or maybe a description of the individual components of the physical system, how we transfer it into digital, let's say, part. But how to connect these kind of things together, and what is going to finally, let's say, the value for the business of that. It's, to me, the most important data in this kind of process of creation, that we identify the most important parts in entire decision-making process to bring the value. Well, I was talking about enablers, but on contrary, that's the same for let's say the challenges about to bring the people who are going to use that kind of thing at the very end, the understanding about how it works. And I'm not speaking about how it works in the terms of bringing the model up to the speed and things like that. This is the technical part, but about how the components are talking to each other and where are the critical points on implementation and on the maturity journey. So that would be my view on it.
Outstanding. I completely agree. We did get some questions from our audience. Peter, a couple people are asking about that maturity scale that you mentioned, if that was publicly available. If you could.
Yeah, I'll send a link. I've responded just to say that I'll dig out the link after this and make that available.
Two other quick questions here. One, you for Steve. Within your organization, you've been able to drive real-world business value out of your digital twin platform. In your opinion, which stakeholders in an organization are critical to a successful digital twin deployment? Who did you have to get involved to make this happen?
Okay, so at the outset, we did a sort of stakeholder engagement survey, and we engaged with about 29 people, I think, or groups across Anglian Water's business. We then honed that down to probably 5 or 6 that we worked very closely with the model development. I would say operationally, people could see the real benefit and engaged really, really well and really, really quickly, really bought into it because they could see where it was heading. I think it was probably for us some of the support functions around the business, so finance that support all areas of the business, getting them, I think, to a place where they could understand why we needed to map finance costs down to asset level, split fixed and variable costs, and map that into the model correctly. I think that was probably the bit that took the most time and probably most work of our stakeholders. Yeah.
Excellent. And Steve, Mark, to kind of round that out, once as you've been engaging in this process, for somebody who's just beginning in this journey, what would be an expected timeline for a digital twin implementation from concept to value? What does that timeline look like, Mark? No, I'm sorry, I meant to Mark, sorry.
Yeah, no, that's cool. I guess in many ways that depends on the complexity of the application. It depends on the technology that's been utilized. But in the case of the project that we've been talking about here with Anglian Water, deploying the advanced business twin from BMA's perspective, we already have a kind of core platform that we build on, and typical implementation for us is a 3 to 6 month project, and in that particular case for Anglian, that entire mapping of the end-to-end of the bioresource business, all of the dashboards and scenarios that we kind of run with it, we're all done within that timescale. So for us, it's about being really agile. It's about seeing the opportunity, and it's about driving quickly and driving the value hard. And just to kind of build on a point that Steve made about where you typically get the advocacy, it was also important for us in Anglian Water that we had support of 2 of the main board directors. We had a guy that was leading the kind of procurement and part of the business, and more importantly, the operations director. So getting C-suite engagement with digital twins is really, really, really important.
Yeah, that's key advice right there. And with that, I'm going to conclude and wrap this up. This has been wonderful. It's been very engaging. I like the fact that it was very, very real world, some practical advice. And the panelists here, industry experts, you did a great job. And with that, I'm going to turn it back over to Travis and Swan.
Thank you very much. That was quite a lot of information and great panel number 2 here for the day. We have a lot going on moving forward for the second half of our day. And just to sort of set the table with that a little bit, at this point in time, we're going to utilize the interactive sessions link provided in the emails that you've received and the attendee guides for the roundtable sessions. We've also just posted that on the chat box, so you can click to join. We're also going to be taking about a 10-minute break before we go to those interactive sessions. So before you go on break, please join immediately to ensure that you're at the correct roundtable. So go ahead and click the interactive sessions link. That's going to take you to the appropriate roundtable. And then we're going to take a 10-minute break, and I will join everybody on the other side and bring everybody together here, and we'll enjoy some interactive roundtable discussions before coming back here. So go ahead and click on the interactive sessions link. We'll take a 10-minute break after that, and I will see everybody on the other side. Welcome back, everybody. It is time for panel number 3. Lots to cover here still for today. Panel 3 is titled Actualizing the Benefits of Digital Twins, and the moderator for this panel is Bob Taylor. And as you all can remember, I like to drop a little bit of personal information from our moderators. And one of Bob's fun facts is the fact that he's actually a musician in his spare time. And believe it or not, he's the first person that I've ever met that has done this, but he actually made his very first album when he was 9 years of age, which is quite a feat. I actually think that year he also opened for Bon Jovi on tour. I'm not sure. He can validate that when he comes on. But on a professional level, Bob has 35 years experience in the global water industry and is currently CEO officer of Portsmouth Water. Prior to this, Bob was the operations director in drinking water services for Southwest Water, part of FTSE listed Pennon Group. Bob joined Southwest Water in 2016, following Pennon's acquisition of Bournemouth Water, in 2015, and he held the position of managing director and director of operations. Prior to this, Bob was business development director with the Singaporean group SemCorp, and responsible for the development of municipal water and wastewater businesses within most countries outside Asia, with specific focus on Middle East, South America, and India. So, without further ado, I hand it over to the very talented, knowledgeable Bob Taylor. Bob, take us away.
Thank you, Travis. It was quite amusing listening to all of those sort of transatlantic abbreviations there of FTSE and things like that. But yeah, thank you for that very slightly tedious introduction. Apologies for that, everybody. Just the job title would have been fine. So yeah, we're kind of on the last lap, I suppose. So the team have been briefed to make it snappy and interesting. We're going to be talking about the actualization of the benefits of digital twins. So I guess that's the kind of almost the last step in the process through thinking of ideas, coming up with solutions, making a business case, and then putting them into practice and making sure that that business case actually comes to fruition. So we've got a series of presentations. I'll let each of the presenters say a little bit about themselves, spend about 5 minutes on each presentation, then we'll have a kind of a Q&A session at the end. I'm glad to see Celine is with us as well, so welcome Celine, we've got a full house. So we've got Nigel Watson, who's Chief Information Officer from Northumbrian Water in the UK, Sean O'Boyle, who is Asset Information Development Manager, Northern Ireland Water, just across the water from the mainland, Celine Haya from who is Water Conveyance Practice Leader with Arcadis and also Senior Vice President. Patrick Bonk, who is Software Solutions Leader from Innovise, covering Asia Pacific. And then last but not least, we've got Alberto Di Ponti, who is a Product Manager for Siemens. So we're talking about real life examples here. So as I've said, each of the team will take you through their real life examples. So please load up your questions as they go. So we'll start with Nigel.
Hi there. I sent through some slides earlier on, but I'm quite happy to just talk if that's if they're not coming up. That's okay. I suppose, and I'll just go with the fact that I'm the CIO. I couldn't possibly have an intro that matched Bob. Digital twins are part of our digital water company vision overall, and they fit with what we refer to as the smart networks part of that strategy. Fair to say that, we've put a significant investment, for us at least anyway, into digital services over the course of the last 5 years to bring us to this point. Replacing our billing system, never a fun thing to do, and all of our asset management systems, and integrating SCADA and the asset management systems into the cloud, into a data lake. And so digital twins and our approach to digital twins, I guess, is technically underpinned by a good architecture. I mean, modern architecture. It's not to say that our data is perfect, far definitely not, and would never be. But our approach is good enough, and the more insights we get from using it, the better it gets. And for us, a digital twin, I guess our definition just and everybody perhaps has their own, and that's okay. I just is that it's live for us, or near live. And so the idea of the digital twin is it informs mainly our operational people to make better operational decisions. So we're feeding data into the digital twin. We're running massive simulations in short periods of time, harnessing, if you like, the elasticity of cloud compute power, and then generating an outcome or a set of outcomes. At the moment, I mean, we don't really sort of close the loop automatically. We've left the human in the loop. We think that's probably the right thing to do. So we leave the final decision as to whether they accept the recommendations of the digital twin, if you like, with a human being. And I'll just talk about a few examples. So we have Aquadapt. This is our distribution system optimization. So, you know, we've inherited a lot of our assets. They've been built in places that if you were starting a water company from scratch, you wouldn't put them today. So we have a water treatment works, our most expensive water treatment works. It costs us 5 times to produce a litre of water there, what it does off of our cheapest works. Naturally, though, you know, we have different supply and demand patterns, and so we have to match those. And so what Aquadapt does is take all of that supply and demand information and run that model. We run it every 30 minutes, actually, and we feed back to the operators in our control room a set of updated instructions to our SCADA system. I would say 99 times out of 100, as long as there's nothing unusual going on in the weather patterns, typically, I mean, very unusual, that information is just fed straight back into the 33 SCADA systems that we run. And that saves us, we estimate, between £1 and £2 million a year in terms of operating costs from reduced energy and chemicals. And then we have another digital twin that looks at energy usage, I think, in terms of high cost periods. So we have this concept in the UK of triads. These are 3 times a year, half-hour long periods when the energy tariffs burst, I mean, massively by like times 1,000. And so we have a digital twin that's monitoring weather patterns, the ability of the UK in general to generate renewable energy. So what's the wind doing? And you know, what's the sun doing? Usually not much is the answer, but we model that and look at historic energy usage patterns across different industries. We're basically gaming the whole energy industry, trying to guess when those 3 times a year are going to be. And for the last 2 years, we've successfully guessed 2 of them, and we've been able to advise our operators to, you know, basically turn down the power on anything that they possibly can, and saved ourselves about £150,000 each time we've been able to do that. That's another digital twin. And then we have a non-physical digital twin, if you like, a customer digital twin. So the customer digital twin is basically looking at all of the things that we do that impact customers, and in fact, you know, beyond. So some of the societal things that are happening in our area that might impact customer sentiment and customer behavior, and trying to model that and understand how we might influence CMEX. This is a new part of the measure in the UK in this regulatory period, where we're basically being measured. Half of a customer experience measure comes from what customers think about us, how they perceive us, and so we're trying to get a grip of that and then understand from that how can we influence customers. And so I suppose what we've done so far, I would characterize it, is we've got digital twins that solve one business problem each. And the next step for us, and it's significant because we recognize that we run complex systems. So our next step is to try and join those things up. And that's, you know, going to need an awful lot of engineering and mathematical expertise to understand what is the mathematical interaction between the different digital twins. And I'll give an example of that. If we are able in our customer digital twin to simulate and understand how we could get our customers to reduce their water usage, because that's one of our goals, that would have a knock-on impact on our wastewater system. If our customers were using less water, it would be the sludge would probably be a bit thicker, which would probably have a knock-on impact on our gas to grid capability. And so that's an example which I often use in thinking, how do we knit together these digital twins that we've built in order to be able to understand across the system how we make better decisions. And I'll close there.
Great, thank you, Nigel. That was a really superb sort of whistle-stop tour through a number of different practical applications in your business. So thanks for that. So let's move on to Sean, who is from Northern Ireland Water.
Good evening all. Yes, Sean O'Boyle, Northern Ireland Water. I'm responsible for the development of asset information and systems that consume and utilize asset information. I've been involved with the company for more than 2 decades, and we didn't actually start out with a digital twin strategy whatsoever. We've started out a number of years ago on a very sort of data-centric approach with the asset data known as the corporate asset register in our company being the bedrock of all of our systems integration across the company, from finance to mobile working, scientific services and so on. And we've taken a very low-tech approach this year, but really focused on the data and using that as the common reference across the company. So I suppose for us, if we could just flick on to the next slide, I only have a couple of slides, is, you know, that question, what are we talking about when we're referring to a digital twin? You know, it's all of these things and many, many more. Nigel already spoke about, you know, hydraulic modeling, SCAD and telemetry and various things, and the same for us. And our focus has really been around trying to model our data in a consistent fashion so that it can be referenced right across the company. So whether we're talking about customer information or whether we're talking about financial information, that we're actually talking at the same level of granularity across the company. So we tend to use the phrase smart data. I think we just made that up because the smart processes, smart networks, smart water, all the rest of it. And we keep referring to in our company that you need smart data to enable all of these things to happen. So if we want something on SCADA to be referenced in the same information as the asset management systems or the financial systems, it's the data that needs to be smart to make all of that happen. So just moving on from that then, the challenge for us and the challenge for everybody else in Northumbrian Water and every other utility is really taking that view of the real world. Top left, you know, referring, just using an orthophotography of a wastewater treatment works, and trying to consistently model that in all of our other systems, so we're talking about the same entity all the time. I like the Minecraft analogy, you know, if your 9-year-old kid sits down to build something, what is a single entity in Minecraft world compared to a single entity in a BIM model compared to that in GIS, and so on and so forth. So that's been what we have focused on the last number of years, and we think we've developed a pretty comprehensive common referencing system that will allow us and has allowed us to, I suppose, have that digital view of the real world in our systems world. And the outcomes of that, in my final slide, has allowed us to use that common referencing across the company, no different to any other water utility, but focusing on all of the things, you know, to allow us to make intelligent decisions, whether it's with regard to customers, capital delivery. A huge focus recently for us has been on the whole costing model, where we now are able to look at the costs. Again, Nigel referred to one of his works being 5 times more expensive to produce water than another, no different to ourselves. We have a diverse range of topography, from flat lands around Knockney to hills around the Mournes. We have to supply water to all those, and having that digital twin has allowed us to actually look at those costs, focus in the high cost areas. Can we do something about it? Look at the interventions on the assets themselves. Where are we spending the money? Why are we spending it there? And so on and so forth. So that's a very quick whirlwind of what we have been doing so far with regard to trying to build a digital copy of the real world.
Great, thanks very much indeed, Sean. So I've just put a little note up on the chat there. So if you can start asking your questions on the chat there as people are running through their presentations, that would be really good. So in the middle of the running order here, we now have Celine, who is from Arcadis. Can you see your slide, Celine?
Yeah, sorry, you guys froze up for a second. Of course, it always happens right when you're about to speak. But now I can't see the slides. Can you reshare? For some reason, they're not showing. There we go. So I'll give a disclaimer. I am not an expert in BIM or in digital twins, but I am an expert in asset management. So I want to give you a little bit of a perspective about trying to align systems similar to what Sean was talking about. So I'm going to talk a little bit about asset management and BIM fitting together. Next slide. So if we take a look at the Institute of Asset Management model, you can see that asset management focuses on decision-making over the full life cycle of the asset. So taking the organizational objectives, the stakeholder needs, and trying to figure out the best decisions to achieve those through the life cycle of the asset, during the acquisition, during the operations and maintenance, and even at the disposal stage. So BIM, at least in our world in the US, has traditionally focused on only the design phase of the asset and has not really done much more, but there's capabilities that it certainly can do more. It can be a shared knowledge resource for asset attributes, operations and maintenance requirements, performance of the assets through sensors and other data. It can be a platform that you can collaborate on for decision making, and ultimately, it could be representing your digital twin or your representation of the physical and functional characteristics of a facility. Next slide. So really one of the first steps, and I think Sean touched on this, is you have to have alignment between asset management and BIM. The way you organize the assets, so you have to have a standardized hierarchy. The way you define what is an individual asset, is it the pump and the motor and the panel are separate? Is the pump and the motor together? How much level of granularity do you include as an asset? And then what attributes do you need to collect on those assets, not only for the design phase, but throughout the full life cycle of the asset to be able to manage it properly? Next slide. So we recently did a case study for one of our clients in the US where we tried to integrate some of these things, seeing, how can this concept work in reality? So what we did is we went back for an existing chlorine system, and we went back and developed a 3D BIM model for it. Then we looked at and collected all of their electronic O&M manuals for this chlorine system. And we used a software called WordPress to do that electronic O&M. We looked at the maintenance requirements based on those O&M manuals for all the different assets in the chlorine system, and we created the preventive maintenance tasks within the maintenance management system that they were using, which is Lucidity. And then we did an integration that integrated the information from the 3D BIM with the existing CMMS and with the electronic O&M manual system. So there was just one set of data that was defining what is an asset, one set of attributes, and there was not disparate systems that had different information to be able to effectively manage the assets. So, it was a proof of concept. It can be done. Have a lot of utilities in the U.S. gone down this path so far? Not really, but I think more are considering it because there are benefits to having one system where you're developing this information versus multiple systems. Next slide. So obviously the benefits of doing this is you have one-stop access to asset information, right? So I don't have to go in, if I go in the CMMS, I don't see a different asset definition or asset represented versus if I went back to the BIM model. I'm not doing duplicate efforts. A lot of the asset management projects that I've worked on, we have to go in and do a inventory and condition assessment is like the first step. And so we're defining all of that. If it was defined during the design, then, you know, it could just feed into the maintenance management system versus having to do a very field intensive inventory to get all those assets in for proper operations and maintenance. Obviously, it promotes a better understanding of the asset through its full life cycle, and again, helps you do the maintenance throughout that life cycle. So that is just a little perspective of how systems can play together and reduce some duplicate efforts and also provide better management throughout the asset life cycle.
Thanks very much, Celine. We're starting to get a few questions coming up now, so please continue to ask away. We'll come on to those in a few moments when we've completed all the presentations. So next we have Patrick, who's going to, he's from the Innovise Asia Pacific region. Patrick.
Hello, good morning. Thanks, Bob. I appreciate the intro. I'm Patrick Bonk, Software Solutions Lead with Innovise, and I've been working on really interesting ways to address challenges associated with adopting emerging technologies at scale within organizations. So my brief run through today looks at how digital twins have been adopted to meet the day-to-day workflows of its users. So trust in these systems has actually reached a point where predictive alerts actively support health and safety decisions, and even more so inform the operation and networks with real-time AI recommendations. So to articulate how best to align the core concepts of the digital twin, so specifically here, these complementary technologies at the level of the asset, so operational analytics, predictive operational modeling, predictive AI, is to contemplate the time horizon in which you're solving your problem and relate to the actual problem and objective you're looking to solve. So my goal here is to make these concepts accessible through adoption success stories with their respective organizations. And I'll give a brief walkthrough through 3 unique use cases and how it relates to what I'm articulating here, the sequence, the timeline you see in front of you. So the past, the present, and the future conditions at the level of the asset can now be applied with digital twins. So on to the next slide for our first use case. In short, operational analytics, they inform the performance and operations of your network. So you have disparate data sets, large amount of data, but how does the user actually interact with the software? So our cloud-hosted application has been designed to be utilized on a daily basis, and it includes mapping geospatially located sensors, alert mechanisms, and workspaces the user can build based on the specific persona type within the organization. So the workspaces themselves are informed by the data modeling application. So this particular platform allowed Cardno to establish real-time direct connections over manual downloads and spreadsheet work. And they were able to streamline and standardize their network performance calculations. And then also, because you're dealing with larger data sets and directly connected data sets, look at long-term seasonality considerations over the longer term period of time. So the outcomes of this particular project, Cardno estimates savings of up to 8% on energy costs by responding to significant drops in the pump efficiency versus, say, targeted pump refurbishment, and another 5% just on improving the sequencing. So one thing that was nice about this project was they started at a pilot level, and then from their initial analysis, they're able to scale it. Wellington Water is looking to scale to the remaining 300 pumps within their network. And they're looking to continue to use Cardno's expertise on the project. So transitioning to operational models with our next use case, we can actually predict the future hydraulics of the network at the level of the asset. So with the second case here with Thames Water, why use an operational model? Well, essentially, sensors aren't available in all parts of your network. So you look to supplement that visibility with a hydraulic model. And because it's a digital twin, it enables what-if scenarios on predictions on, say, an incoming storm event. Does changing the operation of the system prevent flooding or spilling? You know, so what-if scenarios: will a spill happen, when and where? Has a blockage occurred? And, you know, maximizing storage in your network, and then also forecasting flows to your treatment plant. But how do you tell, from a user standpoint, an operations team, you're going to adopt an operational hydraulic model? Well, you don't, because they won't. It's going to be perceived as too complex. So at Thames Water, initial interactions with the software began by simply utilizing spatial rainfall forecasts to understand prospective network impacts of those incoming events. Then they reached the point where the alerts were trusted to support health and safety decisions on person entry into live sewers. Okay, so one more segue. With this technology here, we have the ability to predict network happenings before they occur and predict flows to the treatment plant. So, which leads us to predictive AI now, where the technology can provide recommendations on how to operate your network. So next slide. So with our AI, we can actually abstract out any process schematic for a wastewater treatment plant, a network, into a real-time predictive model that accounts for changes in weather, how the environment changes, system changes. The significance here is it's real-time over, say, just historical analysis. For this particular case, compliance standards were actually becoming stricter by the year due to tightening regulations. So what we were able to do up front with them was you can operate and still actually achieve these savings with tighter regulations. So the predictive AI, the platform provides recommendations so the operators can reduce their energy and chemical costs and increase system production. So for this particular project, they were able to save 29% on just energy costs. So to link these three kind of use cases together, from evolving network conditions and evolving compliance as seen with this, the need for digital twins is accelerating with the challenges we're confronted with. So just next slide. So strictly from a network behavior standpoint, we have greater uncertainty and evolving conditions. So increased blockages, shifting locations of the blockages, weekend patterns are becoming weekday, and what are the consequences of these changes? And then from a user needs perspective, if we think back to the user, you know, everyone's been adjusting from working from home, IT license and corporate systems and access to data, collaborating remotely. So among these three use cases that we've covered, as I said, the past, the present, and the future conditions can be applied with digital twins. And if you think of the three examples, to get started, focus on the problem you're solving. You can actually start with a simple use case and build from your existing systems that are already in place, the work you're already doing, and understand how those workflows can be improved. Understand how the user interacts with the digital twin on a daily basis. And the workflows now exist to serve operations for their rapid decision-making needs through to executive level management for their higher level decision-making. So the use cases of these digital twins now are beyond just engineering teams, and workflows actually exist for the wider group, the wider range of personas within a utility and a council. So that's it for me.
Great, thank you very much indeed, Patrick. So we're running behind time a little bit, so we'll finalize the presentations with Alberto, and then we'll move on to some questions and answers, hopefully. So Alberto is a product manager from Siemens.
Yes, thank you, Bob. Indeed, I'm product manager and my background is on simulation. So what I would like to do today is to give you a perspective of what is a digital twin in our opinion, starting from the simulation side. So in my opinion, when we talk about digital twin, we often think about technology and usually about complex technology. But in reality, at least to me, the digital twin is not about technology. Rather, the digital twin is about people and process. And to me, a digital twin is about helping people having better lives and making the process more efficient. And technology, in reality, is just the tool that is serving this value. Let me try to explain this point and this vision. So if we think about the water industry, and as many other industries, in this industry, the engineering team is designing the system, but is loosely connected or even completely disconnected from the operators teams. And this is where the problems and the increase of cost occurs. So if we look at the process itself, we can identify three main phases: the ideation, the realization, and the operation. And in the ideation phase is when the system data, that can be GIS, CAD, or BIM, are used to automatically create the simulation model, which is the core of the digital twin. And a good example of this process is given by this example that I'm citing here, where Keo Meyers and JS Pump Fluid and System Consultant have used simulation to design and analyze the water supply system serving the new Brisbane West Wellcamp Airport. And as they say, the static and dynamic hydraulic modeling that was performed in SimCenter Flowmaster assist in optimizing the critical plant component and result in lower life cycle cost and more reliable operation. So now, once this is the let's say the engineering phase, and once the digital twin is or better, the system is designed and optimized, it is the time to build it or to commission it, right? So this is where the digital twin can be reused in order to get more value. Because the reality is that in the water system are not like cars or planes for which you can build a prototype or an iron board. The problem in this industry is that prototypes are not available. We cannot do prototype, and systems must be right from the beginning. So now there is the opportunity to reuse the hydraulic model that we have created in the ideation phase and connect it to the control and automation model. And both these models can be operated synchronously by means of an operator dashboard. This is what we call virtual commissioning. And the key point here is that virtual commissioning allows us to operate the system in a completely virtual environment before it is built. And this allows us to explore the response of the system, of the water system, to different conditions. In this example, there should be a video that is moving, hopefully. We can see an interactive dashboard that is representing the pumping station and the water tower of a larger water supply system. But what is important is what is behind the scene of this dashboard. Behind the scene, we have a dynamic hydraulic model that is running synchronously with the automation and control system model. So this is where we can operate the system before it is built. But this is also a stepping stone to move towards another phase, because leveraging this connectivity between the virtual hydraulic model and the virtual control and automation model behind an operational dashboard, we can create effective operator training tool. And this will improve the knowledge transfer between the engineer and the operators. If we do this, the step to move forward and go towards the direction of operation is now very small, because instead of connecting the hydraulic model to the control model, we can connect the hydraulic model directly to the control and automation system of the real system, so the PLC system and the SCADA system. And now we can run this digital twin in real time while the system is operating. And this will provide important information to the operators. Couple of examples. The digital twin can provide information at locations where sensors are not available. This is what we call virtual sensor or soft sensors. But another more interesting example, in my opinion, is that the digital twin can compare the simulation results with the measured data that are coming from the real system, and by comparing these two information can detect malfunctioning like leakage, for example, and automatically trigger alarm if it is necessary. Now, it is important to note that this virtual system is completely hidden behind the operator dashboard. So this means that there is no need for any additional training for the operators, and there is no need for the operator to learn any simulation tool, which honestly sometimes can be a bit frightening. So this process where the digital twin runs in real time behind the operator dashboard is what we call executable digital twin. Now, we have a final step, in my opinion, to do to implement what we call continuous digital thread or continuous engineering. And the step we need to do is to close the loop by gathering the data from the real system to continuously update and improve the fidelity of the digital twin. And this is something that we can do by leveraging the industrial Internet of Things and leveraging the artificial intelligence and the machine learning to automatically fine-tune the digital twin. Now, this is the vision of what we call continuous engineering or continuous digital thread. And I understand that maybe this can look a bit technical, sometimes complex, but the reality is that this is something that we can do today because engineers can continue to happily use simulation tools to build the digital twins, while operators do not need to learn any new tool, any simulation tool, because the power of the digital twin is completely hidden behind the familiar dashboard of the operators. So this is a technology, if we look at this in this way, this is a technology that improves the efficiency of the system of the operation by improving the communication by the engineers and the operators. So I like to conclude by saying that I really think that the use of the digital twin will not only make the process more efficient, but will also make our environment better and ultimately our lives better. Thank you.
Great, thanks very much, Alberto. So we've got some time now for some questions and answers. There are a couple on the screen there, which maybe we can use to start with. I think the first one is there for Nigel, and it was talking about the kind of, you talked about separate digital twin systems that you had in different areas of the business. So the question, I guess, is that a better approach, or should you have an all-in-one integrated solution? Maybe that's too big a step to take in one go, perhaps. Anyway, what are your views on that, Nigel?
Well, Bob, I think it would be too big a step in our organisation because I think I would probably be going to Heidi, you know Heidi very well, and saying, Heidi, I need £20 million. I'll create an all-in-one digital twin. I'll see you in 5 years. And I mean, she'd never buy into that. So I think the approach that we've taken is to be pragmatic and not to over elaborate, actually, which might sound a little counterintuitive, on the business case for each one of those digital twins, because the reality is before we started work on them, we didn't really know what value they would deliver. But what we have been able to do, you know, taking that one at a time approach, is cash checks along the way. And so we're constantly going, okay, we take a little bit of investment, but we deliver business value in the form of, and it can be in the form of money, right? So it's more efficient, for example, to produce water, but it can equally be in ODIs, which, you know, like we're reducing. So we reduced our category 3 pollution incidents using that digital twin by 80% in 1 year. So I think it's really important in our organization, and I guess most of you be the same, to just demonstrate value every step of the way. I suppose the difficult bit that we've got ahead of us is knitting them together. And yeah, we've still got that work to do. So I might ask me at the end of that. I might say it would have been easier to buy one big one, but then I'd have probably had to wait 10 years.
Great, yeah. I mean, there's another interesting question here about challenges in setting up digital twin systems. And I think one of the themes that has run through the presentations we've just had, it was around the human factor, particularly Alberto's presentation at the end there. And, you know, I would extend that challenge from not just the people who are using the systems and getting the value out of them, but getting the decision makers on board and integrating them with the business case and getting them sort of completely on board with the ideas. So what do people think in general? I'll open this question to everybody, and just stick your hand up if you want to comment on it. Well, what is the biggest challenge here? Is it the technical challenge in terms of creating the systems, the modeling, the hardware and software, the thinking that goes behind that? Or is it getting people involved who will get benefit from those systems? Anybody like to have a stab at that?
Yeah, Sean here. I certainly think one of the biggest challenges is not around the systems at all. In fact, we don't like to talk about systems when we're talking about digital twins, because for me it's all about trying to get that top-down, utility-wide buy-in, the people, the process and whatnot. But in order to do that, it's all about the language and trying to explain to those decision makers, the people with holding the checkbooks as such, and explain to them what the benefits can be. And I just think our whole industry sometimes is a bit awash with lots of jargon and technology and whatnot that really just confuses a senior executive who's going, what are you actually talking about here? So dumbing the language down and trying to explain in real terms what the benefit is. Why would you bother doing this?
Yeah. Celine, I think you wanted to come in on this one as well.
Sure. I mean, just basically related to asset management principles, what Sean was saying, you have to have some line of sight, right? So how does this system contribute to your overall objectives of managing your assets? And how does that flow down to the people day to day that are touching those assets? What's in it for them? You can have the best technology in the world, but if no one embraces it, then it's not going to give you the value that you think is going to happen.
Yeah, I mean, I've got a bit of a theory about this, in the sense that, decision makers, people who make the final decisions about adoption of this technology, normally there is some significant investment involved. You have to try and see that investment is worthwhile for whatever reason. But it seems to me that digital twins are delivering huge success very, very rapidly in saving energy costs, which obviously has wider benefits than financial. And, there's nothing like a bit of low-hanging fruit to get people enthused about, a project. And I think for me, saving energy costs is probably the low-hanging fruit of the digital twin world, because it seems that there's been quite a track record of people being able to do that. I mean, Nigel just mentioned that earlier on, I think one of the other presentations as well. So I think that's something that's really important to bear in mind. You can do some relatively simple, it seems to me, straightforward digital twinning and AI on the back of that. And I think, oxygen delivery in a wastewater treatment system was mentioned earlier. People have saved massive amounts of money in that area alone over the last 10 years. So anyway, enough of that from me. Let's have a look if there's any other questions here. So question about whether it's better to develop these systems in-house or to buy, proprietary software off the shelf. Any views on that for any of the panel?
Bob, if I may, I think we use a combination. It's whatever is right. So, if we've bought a pump from a pump manufacturer and it comes with a digital twin, because we would ask for that, we're going to use that digital twin, right? Okay. We'd start with that. There have been cases where we haven't been able to get something off the shelf, and we've developed the algorithms ourselves and with partners. And I think the trick, the skill you need really is in data integration.
Yeah. So you have to be able to join them all up together.
Yeah, exactly right. Yeah.
Your next challenge anyway, with all your various systems. Any other views on that? Patrick?
I would say we have out-of-the-box solutions that integrate with your existing systems that are in place. So if I were to give thought to the amount of effort that would take somebody to build an operational analytics platform, whereas instead the workspaces are available for you to use the data modeling application and build up your analysis from there. And then if you think of, some of the elements of a hydraulic model, now that they're live, they're connecting direct to the data sources, the data you're already collecting. So a lot of these systems can actually integrate with what you're using already to build from. I don't think it has to be an either or proposition.
Sure.
Yeah, if I may add to this, of course, I'm on one side, so I'm responsible for software that delivers this kind of vision. So of course, my view can be quite easy. But the reality to me is that the point is not really about the single point technology itself. As you were saying, Bob, the point of a digital twin is the capability to intercommunicate and exchange data between many different players, human players, but also many different pieces of softwares. So whatever is going to be the solution can be fully in-house, fully bought from a provider, or in a hybrid of these. I think that the main challenge and the main focus should be on the integration of the data with as I was saying in my talk, with a specific focus on sharing or making sure that the knowledge and the know-how can be easily shared between all the players in the digital twin, starting from the engineers and going down to the operator and back, because the closing loop, the step to close the loop is essential in my opinion.
Yeah, I think also, I think you touched on it, but I think the vision thing is quite important. I think I always think I've been in the industry a long time, as those of you who know me will know. And one thing that I always come back to in my sort of visions that I've heard from various water leaders around the world is the Singapore situation, where, they had a vision that's from the 1960s, really, that's still playing out 100 years later. They had a vision, they stuck with it, and they're still delivering it. And I think, this is part of what we need to do with digital twins as well, to have a vision for where we want to be. I mean, I've always dreamt, since I was young in the industry, I was building network models. That's what I did in the 1980s, with all that manual technology that we had, so-called, in those days. And the vision was always to put it in the hands of the guys operating the system, so they can see the impact of decisions that they're about to take, ahead of time. And that's just literally, well, it is in place now in some areas. We're just around the corner from it in my company, but I think you need to convince people at decision-making level that, those visions will actually lead to something really worthwhile. And as Nigel said, sometimes you just have to take a punt on things and have confidence that it will deliver. You're not quite sure how much or how, but you just have an instinctive feeling that will happen. So I think I think instincts and business cases are important, but I think having a vision for where you want to go, a roadmap, is also really important as well. I'm just looking at the clock. We did start a little bit late, but I think it's probably about time that I concluded the session. So I hope you've enjoyed the presentations, all of you in the audience, of which there are 85 according to my screen at the moment. I'll say special thanks to all of the presenters. I think you did a great job, and I think that was an interesting debate at the end. So thanks to all of you, and I'll now hand over to Travis to, I think, conclude, or is Gigi going to conclude? We can't hear you, Travis.
Sorry about that. Great job, Bob. Great job, team, on panel 3. I'll take it. And then I would just want to thank everybody that was involved in this panel, and the previous 2 as well. We learned a lot today. We covered a lot of ground in the past 4 hours. But I'd like to hand it off to Gigi to give us some concluding thoughts. So Gigi, you want to take it?
Absolutely. Thank you so much, Travis. So, wow, what an incredible workshop. 4 hours, they definitely went by very fast for me. I enjoyed every single presentation, really enjoyed the roundtable as well. I hope all of you did. Learned a lot. I think there is definitely a lot of great experience going on all over the world. Different utilities are trying different things. But one thing that kept coming up over and over again, there's still some challenges. And there's these challenges that we can collaborate, come together, work together to solve them, and come up with best practices. So I'm really hoping that's what everyone got out of this. You know, lots of great innovation. I just want to thank everyone for their participation. I want to especially thank the excellent speakers and moderators and roundtable leads for your leadership and for great content. I want to thank our sponsors again, Idrica and Innovise, for your sponsorship. I also want to thank Travis. Thank you so much for keeping us all aligned through this great workshop. And of course, I cannot you know, forget to thank Amir, Shana, and Sapir for all the work that they did behind the scenes. I realize, you know, a virtual workshop is a lot more intense than having a physical one sometimes, but everything went smooth. Thank you, everyone. And I would also like to thank all the attendees. I know at some point we had well over 200 attendees. Right now, it's probably in the middle of the night in some of these places. But I want to thank everyone for joining. It was fantastic, fantastic participation. And please, I invite all of you with your great ideas, come together, let's work together and solve these problems once and for all of the water sector. Thank you so much. Thank you.
Oh, that concludes everything here for the night or day, depending on where you are in the world. But I want to thank everybody. Thank you, Gigi and Swan, for the opportunity to MC, and everybody, like Gigi said, come together. This is a big moment in our industry, and the digital twin, there's a lot of opportunity there to be positioned as thought leaders and move everything forward. So thank you, everyone. Have a good night, day, morning in some places, and I hope to see everybody very soon.
Thank you. Good night.
Bye, everyone.
Goodbye.
Thank you. Take care.
Good night. Bye-bye.